Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert level science. I'm Ken Hansen, Associate Professor in the Department of Chemistry and Biochemistry. I do all things light matter interaction, photon driving chemical processes. But more importantly, joining me today is Dr. Ted Kolberg. Ted, if you wouldn't mind introducing yourself.
Yeah, so thanks. I'm Ted. I work in the physics department at FSU. I'll be an associate professor next fall.
Congratulations.
And my main area of research is high energy physics, and specifically I work on the CMS experiment, which is one of the big general purpose experiments at the Large Hadron Collider in Geneva, Switzerland, that tries to find new particles, new forces. And I also work on developing the technologies that will enable us to do like future rounds of experimentation. So improving our ability to ask and answer questions which we couldn't do today.
Awesome. Equally important, what game are we starting with?
We're going to start with a childhood favorite, The Legend of Zelda: A Link to the Past. All right. So this game's from 1991, probably came out in Japan in 91 and like the rest of the world in 92. I don't think I had a Super Nintendo maybe until the following year, but I definitely spent a lot of time playing this game.
It's classic. So I had to look it up. So the Zelda franchise has 27 games, and this is the third in the sequence.
Yeah, at some point, don't they try to like... I read somewhere that in like Skyward Sword or something, they try to have like a metafiction that ties together like different worlds that all the Zelda games occur in.
I respect that. Got to stay true to the lore. You know, the fans demand it. Bronco, welcome back. It's good to see you, or good to see you in chat. Welcome.
So the story is that this evil wizard took over the castle, and I don't think he's my dad. He's my uncle, maybe. He's gonna go do something scary in the dead of night. I gotta follow him.
No worries. I'll let you settle in before we open for questions, because, you know, just get in the groove, have half a beer in you.
Yeah, I'm obsessively collecting these hearts that I don't actually need, but if there's a pot, you gotta grab it, right?
Zelda, you have to break everything in sight. Just go in a random shop and destroy everything.
I can't cut the bushes yet because I don't have a sword.
So do you remember most of this? You remember where stuff is? And
I think so. At least the first. So it's spoiler alert for like a 30-year-old game, but there's like a parallel universe that you start eventually like fading in and out of, and some of the puzzles you have to. It's a mechanic which has been like used a lot of times since, but I think probably one of the first games to have this idea where like you got to go to the other world to like change something, and then it will affect the first world that you were in. So probably, I don't think we'll play long enough to get to the point where we're using the magic mirror a lot, but I think the dungeons in the second half of the game are a little more difficult and complicated. I probably wouldn't remember all those, but this early part, I must have played this 100 times. I'm barely even thinking. My thumbs are just doing all the work.
Yeah, so I didn't play the original Zelda. I played the second one, the Zelda 2, which was hated by most people that played Zelda 1, but I loved that game. I will argue that's the better Zelda of the two NES games.
It's a game about being a teenager, right? It's about how like people are always asking you to do stuff and you can't always help them.
Find this, deliver this to this person. Here's some magic, have fun. Yep.
Yeah, I guess this Zelda game is from before the kind of like open world RPG formula really coalesced. So one thing I like about this game is there's no like, there's secrets, but there's not like a bunch of just like side quests, fetch quests or whatever. It's like you're working pretty single-mindedly on like solving a pretty clear scenario and not a lot of distractions.
I mean, a lot of these Super Nintendo games were really good at, they're still linear, but they don't feel as linear as the two-dimensional side-scroller. And yeah. I think this was one of those that, I mean, there are secrets, but for the most part, you know where you're going and it's directing you the right way. All right, so we should open up for questions. If anyone has questions for Dr. Ted Kolberg, he's happy to talk about the LHC, about high-energy particle physics, Higgs bosons, whatever you guys want to talk about. He is excited to answer those questions while playing Zelda for the first time in like 30 years. So no pressure. All right, Calm Down Bronco wants to know, how is antimatter created by a particle collider?
It's a good question. And I could almost reframe the question to ask in a way that would be maybe even a more physics-y way of asking the question. So we think of antimatter as this like rare and exotic substance because we live in a world which is completely dominated by normal matter. But actually we don't understand on a basic level the reason why this should be the case. Like, actually, matter and antimatter are created in equal amounts in all of the interactions that we study. So the fact that the universe is mostly made of matter and not a lot of antimatter around is actually a real puzzle. So we know that there's some symmetries of nature, and we could talk more about what exactly a physicist means when they say symmetry. It's related to, but not exactly the same thing as what people use symmetry to describe, like a painting or whatever. We know that some of the symmetries of nature are a little bit broken, which means that there are approximate conservation laws that aren't exactly true for every kind of interaction. And it seems that matter and antimatter is one of those cases where, even though most of the experiments we do produce matter and antimatter in equal amounts, there are some reactions which are known to violate that symmetry. And actually, I don't think that the chapter is not closed. I mean, we haven't found enough asymmetry to explain the universe that we live in. So why is the universe made of matter and not antimatter is really an active research question. But to answer the original question, when you pack a lot of energy into a small area of space, that's like not a stable situation, right? So you smash two protons together, you concentrate a lot of energy into a really small space, basically a space the size of a proton or a fraction of the size of a proton. And it's energetically favorable for that energy to result in the creation of particle-antiparticle pairs. I like how if you say, I don't understand, they just literally repeat the same thing endlessly, prefacing it with, listen carefully.
Yeah, as if it'll make a difference.
Interacting with my students sometimes.
Yeah.
So yeah, the most like obvious particle interaction that you could draw is to have like a electron and an anti-electron collide into each other. That produces a high energy photon is what is exchanged between those particles to allow them to interact. But matter and energy, momentum and energy conservation dictate that photon has to immediately decay back to two more particles. There's no way for energy, if you just write down the equations for energy and momentum conservation, you can't have this like 2-to-1 annihilation. What you end up with is a new pair of particles can be created. So that could be the same particles that were in the initial state. So you could make another electron-positron pair, but could also be new particles that weren't present in the original state. So you might create what we call hadrons, protons and neutrons, which is what makes up the majority of the mass of like you and me. Those can be created if there's enough center of mass energy available in the collision to make up the rest energy. So E equals mc squared, the famous like Einstein equation that tells you how much energy you need to create a certain amount of mass. It doesn't really answer the question, I realize that. That's how we think about it.
Yeah. I mean, what's funny, the symmetry breaking in physics, I mean, biology has their own symmetry breaking problem. I don't know if you're familiar with this, but chirality and molecules being left-handed or right-handed, like most of our biomolecules have a specific handedness. Our proteins, our DNA, and we have no idea where that came from.
Yeah, right. There's the idea that if you like went to another planet and it would look like a lush jungle or whatever, and you like eat the food and it just passes right through you because it's like the mirror image of all of our molecules. And it just wouldn't interact with like your biology, or it probably would interact in an unpleasant way.
Exactly. Yeah, and we have no idea. There's hypotheses about like quasars and supernovas creating chiral light that creates something that happens, circularly polarized light that induces one over the, because you only need a slight bias and then all of a sudden it propagates through. But where does that initial bias towards left or right-handed come from?
Yeah.
No idea.
So all these questions that we're saying, like, why is it this way and not that way? Some physicists would tell you that actually that's a bad question to ask, that it's just random. And we just happen to live in a universe where the random parameters settled on a value that's favorable for like us to exist, but that there's no like dynamical reason why it has to be that way. Like maybe most of the universes out there are just completely boring and contain no structure of any kind, right? That would be the simplest universe to write down, just like a uniform gas of photons with no matter, no nothing. Maybe most universes are like that. I guess intellectually I can appreciate the reason why that might be true, but for my money, it's an unsatisfying answer to the question. I think we should try to find, wherever possible, dynamical explanations for why things are the way they are. And when I say dynamical, what I mean is that there's an interplay of like forces working against each other that creates an equilibrium. That's like a kind of an explanation that's really appealing to a physicist.
Man, that seems so defeatist. Just saying, it's essentially just saying it's because that's the way it is, right?
Well, you have to realize that theorists
right?
in my field haven't really made that much progress in arguably like 30 or 40 years, right? So you can see why people would start to get desperate.
Yeah.
We're in the situation now where there's a few well-known problems that people are working on. Things like the masses of the neutrinos. It's kind of like known that this is something that requires an extension of the standard model. It doesn't seem like that doesn't really break anything to put that in there. But then other problems like what is dark matter made of and stuff, those seem like they require new explanations. And certainly we haven't experimentally been able to answer that question. So I still hold out hope that we'll discover that there's a really big and beautiful symmetry or law out there which explains like why the universe looks the way it does and not some other way. But it's an open question.
I mean, that's interesting. So like at 1900s, when there were people out there saying physics is solved and all of a sudden quantum mechanics and relativity come in play. Now people are like, physics can't be solved. It's inevitable somebody's going to come up with something new, right?
I mean, one of the biggest forces in human nature is like status quo bias, right? That people just figure whatever's happening right now is going to continue happening forever.
Yep.
And it's very rarely the case.
Yeah. That makes sense. All right, Ninja Man, thank you for the follow. Enjoy your standard internet units. We'll bet on some questions in a little bit, predictions that is, but enjoy your standard internet units. You can unlock emotes, but also throw your questions in chat. If you have any questions for Ted Kolberg, he's happy to answer anything about high energy particle physics, smashing particles into each other at 99.99 whatever percent the speed of light. It's a lot of nines. How many nines is it actually?
I don't know. I would have to look it up. It's a pretty useless unit. In high energy physics, we usually just set the speed of light to 1. So thinking of things in terms of fractions of the speed of light isn't usually the most useful way to think about it. We create these relativistic variables that correspond to actually how much things change rather than what the speed is. So there's this number gamma that we use a lot, which is derived from how fast you are compared to the speed of light. But it tells you, like, you may have heard that, for example, this idea of the twin paradox, that if like one twin gets on a relativistic ship and goes to Alpha Centauri and back, his twin back on Earth will age 10 years while he only ages, however long, this factor gamma tells you how differently time passes for the two different people. So in the case of the LHC...
So we had that experiment recently, right? It was a twin that went into space and was in orbit for like 9 months or something like that. Isn't that true?
You're talking about Gravity Probe B?
No, it was one of the astronauts had a twin back on Earth. So I think they actually calculated a gamma for it. Yeah, like they did the math. I mean, it's subtle,
small,
right? It's not traveling light years away. But
it's not completely practically ignorable. For example, GPS satellites, there would be a drift if they didn't compensate for this relativistic effect. It's hard to find everyday examples. One of the things I used to do in my class when I taught Physics 2054 was that I had a computer program called a slower speed of light that would basically no one has seen him. We went to the wrong village.
No.
I'm sorry, I was talking about
we're talking about gamma values and relative to...
So in the case of the LHC, this factor gamma that tells you like how much more energy the protons have than they have in their rest frame. So proton weighs about 1 GeV, and the LHC center of mass energy is 14 TeV. So that's 14,000 times larger. So a proton moving at LHC speeds literally has 14,000 times more energy to it than a proton which is sitting at rest. And all that energy can go into creating new particles. So that's the basic idea of what we're trying to accomplish.
I love that you guys describe mass in terms of EV, like in terms of energy. It's such a counterintuitive thing, you know? Grams, pounds, nope.
Well,
Volt.
I said they E equals MC squared, right?
Yeah,
and I also we said C to 1, so that just means E equals M.
Yeah, so it translates directly. That's pretty fun. All right, we got some follow-up questions here. Particle physics in Zelda, what more could one ask for? The answer is nothing. I guess beer. What are we drinking tonight?
Sierra Nevada Pale Ale, which I first encountered when I went to college in California, and has been one of my favorite beers ever since.
So unfortunately, we have green screen, so you're not going to be able to see the actual bottle, but there it is, the transparent floating bottle.
It's a hoppy but well-balanced brew. It has kind of a bready backbone to it. I'm quite fond of it.
All right, Calm Down Morocco wants to know, how many colliders are there in the world? Are there advantages of having smaller colliders than the LHC, other than price?
That's an excellent question. So particle colliders, well, let's answer for particle accelerators first of all, because there are many more particle accelerators than there are particle colliders.
Yeah.
The only reason you would build a collider is if you wanted to do like basic research in particle physics, and so there's only a handful of colliders in operation at any given time. There used to be somewhat more. There was this idea that you would build like the same experiment essentially, like for example, one version in the US and one version in Europe that could kind of cross-check each other. But the modern equivalent is so massively complex and expensive that it takes the combined efforts in the world to make even one. So there's really no competitor to the LHC. There are some lower energy colliders. For example, there's one in Japan which study very specialized interactions, which you don't need this huge massive energy for. But there's not really any competitors to the LHC. And we think the LHC, I was just looking at a plot earlier today that had the LHC timeline out to 2041.
Oof.
Might run even longer than that. And likely, I think the next collider won't come online until the LHC program is completed. I mean, it's already 2022, and these projects take literal decades to conceive of, do the R&D, build them, build the experiments, and then take all the data. But particle accelerators are actually kind of a foundational technology for a lot of industrial applications now. One of those is medicine. So if you've heard the term like proton therapy, which is used to treat cancer, that involves using a particle accelerator to actually shoot high energy particles into the tissue of your body. And by some nice mathematical features of the equations for energy loss of particles as they travel through material, you can target very precisely, just damage only the cancer tissue and not the surrounding tissue. Another thing that particle accelerators are really useful for is processing materials in interesting ways. So chemists can use particle accelerators to sort of image chemical reactions as they're happening, basically use the flash of particles arriving as a kind of a high-speed shutter flash to like image a chemical reaction in progress. So I learned the other day that like disposable diapers, a particle accelerator was used to design the polymer in disposable diapers. Basically, they could image the process of these fibers absorbing water like at a very precise way by using a particle accelerator. Heat shrink tubing, which you use to like coat electrical connections and stuff. You can like blow a hairdryer on it and it shrinks down. That is made by stretching the thing out, running it through you run it through a particle accelerator while it's small, and then you mechanically stretch it to be big, and being irradiated by the particle accelerator induces like a memory in the material of what its original shape was, so that when you heat it, it goes back. So actually, if you run a company that makes those, you'll have like a particle accelerator in the basement.
That's fun.
Helping to make that stuff.
So that's like inducing a free volume that can get filled once you heat it. That's interesting.
Yeah, exactly.
Non-dairy neutrino is added. And positron emission tomography, PET scans. Yeah, that's really fun.
So there you're actually using more like the detector part, which is the part that I work on. So in PET scanning, you introduce like a radioactive element that emits positrons, and then those are antimatter, so as soon as they're created, they annihilate with an electron in your body. And this gives off a gamma ray of a very precisely known energy that will only, there's no background to that in your body naturally. So you can make very precise images of biological processes, right? I guess PET scans are useful if you want to see like where the blood flow is going in the organism, stuff like that, because you can introduce it into their bloodstream or their food or whatever.
That's really fun. So colliders in the world, there's a handful, what would you say, 3 or 4 active major ones?
So CERN is the only collider at what we would call the energy frontier, meaning that it's going for the energy record. There are a couple of smaller colliders, one in Japan. There's some even lower energy ones in like Russia. China has a fairly low energy one. But yeah, you could count on 2 hands the number of colliders in the world. I mean, there are some that are still around but aren't really operating anymore at as a physics experiment. So like at SLAC in California, used to be a big particle physics lab. They still run the accelerator, but just to provide this information for like chemists and material scientists and stuff that we were talking about. They're not really in the business of fundamental particle research, at least not on campus anymore.
Yeah,
I mean, they still are involved in the LHC experiments as like just an institute, but they don't run that machine anymore for particle physicists.
So the second part of this one is there any advantage to having the smaller colliders? Is there things you can see with that you can't with the LHC?
Is there any advantage to a smaller collider? Yes. If you know already the energy of the particle that you're trying to create, then you can create that specific particle in like great numbers using a collider of a well-specified energy. So I'll give the example of the collider in Japan at this institute called KEK, which is their kind of national lab, their equivalent of CERN. The idea there is that, referencing back to the conversation we were having earlier about matter-antimatter asymmetry, one of the systems where we know there's a violation of this symmetry is in what's called the B meson system. So these are specific, the B is one of the quarks, and hadrons which incorporate one of these quarks, we've observed that there's a slight difference between the way that the matter and antimatter versions of these particles behave. And so if you want to produce that specific particle, what you can do is run your experiment at what's called the resonance, right? If you run your experiment at the mass of that specific particle, then it's very energetically favorable to produce just that particle in very large numbers. And so if you know what you're trying to do and it's a lower energy resonance that you're trying to probe, that's when you might want to do that.
Makes sense. All right, non-dairy neutrino wants to know, while these particles are so small, but they're going so fast, is the energy and momentum of the accelerated particles enough to create significant gravitational effects, i.e. the energy density is high enough where it's necessary to include general relativistic considerations?
No way, no how, not even close. Gravity is 10 to the 40th, so 1 with 40 zeros after it, times weaker than the other forces that act on the particles. So there is absolutely no way to detect the influence of gravity on single particles. Actually, measuring the force of gravity even on large macroscopic objects is extremely difficult. I mean, Cavendish in the, 19th century had to do these crazy experiments where he was lifting, he had like teams of servants like lifting giant steel balls in like the turrets of his like castle that he lived in, and then trying to measure these minuscule deflections of like a very sensitive little torsion balance due to the gravitational force of these giant balls. There is really hard to measure even the force of gravity on like human-sized objects, much less elementary particles.
I mean, so it's interesting how you frame that, because you said it's hard to measure, but the influence of gravity is non-zero. So is that some unknown or unaccounted for something that could matter? I mean,
you have
small.
to steer the particles like continuously in order to keep them. So you imagine you have a bunch of protons. They all have the same electric charge, right? They're all positively charged, and so they really want to get away from one another in the worst way. So if you just let that bunch of protons fly through space for even a fraction of a second without actively steering them, the protons would just all fly away from each other into like a diffuse gas. So you have to be constantly exerting like pretty large electromagnetic forces on the particles continuously as they move to keep them together. As a result, the force of gravity on the particles is just subsumed into these like much stronger forces that you're having to exert in order to keep them moving.
Mm-hmm. Yeah, that's a fight I have with my colleague Eugene DePrince about quantum mechanics doesn't take into account gravity for the same reason. It's such a small influence. But with quantum mechanics, you have 50-50 events. And if that's the case, gravity might be enough to break that 50-50 scenario. So there's no right answer to this, obviously.
I'm sure that most physicists would agree that there must be a quantum theory of gravity that we can write down. I think there's some like formal problems that make it difficult. The nature of gravity as a force is a little different than the other forces, and so it's it's a little hard to use the same toolkit that we use to describe, for example, the electromagnetic force on gravity for like technical reasons. And the general theory of relativity, which is our theory of gravity, like it's not a quantum theory, and so almost certainly it has to be replaced by a quantum theory of gravity, but no one has yet managed to actually write one down.
So are you optimistic there's going to be a quantum theory or even a like grand unified theory?
Am I optimistic that we will actually like discover it during my lifetime? I mean, I'm pretty sure it exists.
I didn't want to put a timeline on it, but eventually we'll have a grand unified theory, but not anytime soon.
I mean, no one would be a researcher if they were essentially pessimistic about the value of their own field. So I guess I'm compelled to say, yes, I think there's a chance.
An obligation. Yeah, that's fair.
I think a better question would be like, what kind of odds are you willing to put on it? And I'm trying to think of how I would answer that question. I would bet heavily against it if I needed the money.
At least within your lifetime, betting against it is a safe bet. That's pretty fun.
So we've come to the point where I forget how to make progress in this dungeon. If somebody remembers where I have to go.
Does anyone have any input? If Ted's mom is in the chat, she probably saw this game a lot. In the meantime, we can throw a prediction up there. It's 8:30. It's been a half hour. Which one of these guys do you want to do?
Let's do this question. The second from the bottom. Which came first?
All right. So, ladies and gentlemen, if you're not following us, click the follow button, get your standard internet units, because we don't bet on games here. Instead, we actually do predictions based on science questions. So we'll pop a science question up there, and you guys can guess and or know the answer to these. This is Ask a Scientist Gaming Honor Code, where you can't look up the answer using the internet or Google. Just use your own, logic or luck. It is entirely up to you how you answer it. We're going to pop a prediction up there. Use your standard internet units to guess the answer to this question. So the question is, which of these came first? The first London coffee house or founding of the Royal Society? And Royal Society is the major scientific society in England. So which one of those came first? Was it a coffee house or was it the Royal Society? And so we give them about 2 minutes to answer these questions. Throw your guesses in there. Which one came first? And it's United States is relatively young. It's crazy to look back at, like, Oxford is 1,000 years old. I mean, such history behind it.
There was actually a coffee house in Oxford before there was one in London. For the same reason that you find coffee shops by universities today, I'm sure.
Yeah. I had a friend that hypothesized the Renaissance was fueled by coffee and stimulants, and yeah, like as soon as you got people thinking faster.
Yeah. So one reason that I'm like interested in questions like this about the history of science. Sorry, I'll let people finish.
You guys can't see the prediction. Are you able to see it now, Bronco? It should be up there. Click. Oh, there it is. Okay, you guys are guessing.
Oh, maps. All right. That's useful.
That's fun. This is the first one to introduce a map in Zelda. Actually, no, the original one had one. It just wasn't very useful. There we go. Non-dairy neutrino. I can see it. There we go. All right, throw your guesses in there now. We have a head-to-head matchup of which one came first, the first London coffee house or the Royal Society. Betting some solid points here. So these imaginary internet units, we call them standard internet units with the symbol of Xi. Not useful for anything outside of the stream, but fun to do predictions nonetheless.
They would have had to change that if they stayed with Xi as the letter for Omicron, right? But they didn't use it because of political pressure from China.
No. This was made up by us. I asked my quantum chemist friend which Greek symbol I should use.
This is unique to our channel. I see.
Yep,
so why Xi?
He just I like the way it looks. And that was it.
It does look kind of sciencey.
Yeah, and we call them standard internet units because why not normalize that? All right, so the question is, which came first, the first London coffee house or founding of the Royal Society? Ted, which one is the answer?
The answer is the coffee house, but they're not separated by that far, only about 5 years. And I think it's interesting to speculate if there is any causal relationship between the two. So as you started to say before, I mean, some people think of, so I'll use the term drugs loosely to include things like alcohol, caffeine. I think in more creative fields, there's a definite acknowledgement that drugs are kind of like a general purpose technology that can be used to increase creativity and allow people to solve new problems that people in the past weren't able to solve. And I think the same is true in science. You often see huge leaps in scientific activity coming when new drugs become available to people. Another example is cocaine, right? Sigmund Freud and all those guys in the late 19th century, they had pretty unfettered access to large quantities of cocaine. And there's a famous quote by Freud that I love, which he's writing to his fiance, who's I guess back in Vienna or whatever. He went out on the road to give a lecture, and he says, I spoke quite forcefully, which I attribute to the large quantities of cocaine I had taken ahead of time. The audience did not understand me, but that's not important, only that they see that I understand it. And so in some ways, not much has changed since those days. I think it's interesting to speculate, like Steve Jobs and a lot of the other early Silicon Valley people, they also credit, in this case, LSD as being a foundational technology for the whole scene that helped people to come up with new, the guy who invented the mouse was a big advocate for LSD. So I think it's interesting to think about to what extent the history of progress in science and technology is tied up with the ability of people to access drugs.
Yeah. That's a fun anthropology question. I need a guest that specializes in drug use and how it relates to scientific progress.
We must have someone here at FSU. I mean, we have historians of science and stuff. Someone must have.
Yeah, we've been debating. I really want to start branching out beyond science, historians, even musicians, performance musicians or music theory.
At FSU.
Yeah, no, I think it'd be really fun to get those not outside perspectives, but non-traditional, not science perspective necessarily. But yeah, DNA polymerase, that was LSD driving on a road while high.
That guy was really weird.
Yeah, no, it's crazy.
For the same reason.
Yeah.
Yeah, right. So the PCR, which is one of the really foundational technologies of modern biology, the inventor ascribes it to his experiences with acid.
Yep. But kids don't do drugs. Drugs are bad. We'll play NARC later. We'll win the war on drugs. It'll be
That's
fun.
That's right. I'm just setting up the meta-narrative for later.
Yeah, no, that's true. We're going to go full circle tonight, ladies and gentlemen. In the meantime, Calm Down Bronco wants to know, how are these particles and interactions actually detected?
Good question. So this is actually what I spend most of my time actually working on, both making... yeah, sure, thanks. Both designing the next generation of detectors and also analyzing the data that comes from the current generation of detectors. So the basic idea behind pretty much every particle detector is that particles lose energy as they pass through material, usually through, but not exclusively through, interacting with the electrons in the material. Electrons are much lighter than the nucleus, so they're easier to perturb and they're easier to free from the atom. And this creates minuscule electric currents, which can then be amplified. So if you put a material and you put a voltage across it, then when a particle travels through that material, the electrons that are freed up are accelerated by the voltage that you applied, and that can amplify the signal into something that you can detect with electronic counters. And pretty much every particle detector in modern experiments uses some variant of this technique. There are some older techniques which are still used in specific cases. One of my favorite is that if you just expose photographic film, if you just bombard it with charged particles, it will leave like lines on the film. It basically develops the film where the particles go through. And even as recently as the 2000s, people have still used that detection principle. So there was an experiment called Donut at Fermilab, which was looking for evidence of something called the tau neutrino. And the way they did that is they put a beam of neutrinos through a giant stack of photographic plates and just exposed it to the beam for like, I don't know, a year or something, and then take it all apart and try to trace the individual little particles through all the layers. And then you look for this one golden interaction, which is the specific one that you're looking for, the tau neutrino, which decays in like a known way.
Did they see anything useful?
They did. They discovered it.
Okay, that was it.
It wasn't a surprise, but they discovered it. I mean, it was pretty much known to be there, but that turned out to be the most efficient way of doing it.
I mean, it's a pretty low risk, high reward experiment, right? It's not particularly expensive. You just have to let it sit for a year, right?
Yeah, I mean, a huge cubical volume of photographic plates is probably actually pretty expensive, I'm guessing.
Yeah.
Especially because I don't know that so many manufacturers are still around, right? There was a time when there was a lot of industrial capacity dedicated to producing like photographic film and stuff, but I think it's a pretty niche case at this point, right? Who uses it? Like artists?
Hipsters.
Not to like talk down to artists, but it's just it's not like when Kodak or whatever was pumping out like reams of the stuff every day.
And Quentin Tarantino.
Does he still shoot on film?
I think he still shoots on like 35 millimeter,
But if you're doing like a student art film, right? Like most of your budget goes to the actual film. If you're shooting on film.
No, it's
it costs
really expensive.
Tens of thousands of dollars to get like reels of film.
Yeah, I mean that's why back in the day you got one take because it's too expensive to take more. So I don't know anything about this game. Are you making progress?
I am running in circles.
You're going through every room. I think whenever you find new jars to smash, it's new, right?
Yeah, I mean, I'm testing the hypothesis that my muscle memory just remembers how to do everything and find it, and it's not nearly as true as I first thought.
Nostalgia, take the wheel.
I went right through that first castle, right, with nary a wrong step, but
no worries. Yeah, getting lost in this dungeon was why it was so hard for me as a kid. Non-dairy neutrino, if you know where he should go, feel free to throw it in chat.
I mean, I need the big key to open this chest. And the chest contains the bow and arrow, right? Which I need to kill those statue guys. Oh, maybe, did I do this before?
And I mean, this is one of those games where there could be a hidden wall. I don't know if this is...
I don't think
you're
they're
far
that
enough.
mean in the first dungeon.
Yeah.
Anyways, so to continue answering the question, basically you arrange in space around where your collision is happening a bunch of these individual electronic channels. And depending on what type of particle you're trying to detect and what the principle of detection is, some measurements are non-destructive, so we put relatively little material in the way of the particle and allow it to pass through, and then try to reconstruct its trajectory. The kind of detector that I'm working on these days is called calorimeter, which measures the total energy that a particle has, and that's a destructive measurement. You basically ram it into a huge pile of material and cause it to shower, which is our term for basically it interacts so much with the material that it explodes into hundreds of other elementary particles, and then by counting all those up, you can infer what the energy of the original particle was. Every one of those channels then is input into a big system of custom electronics, which makes sense of kind of the spatial arrangement of all of the channels in your detector and has some basic intelligence built in, because the collisions happen so quickly, right? 40 million times per second we collide protons, and every collision now has like order of 40 or so proton-proton interactions overlaid on top of one another. And then we do that 40 million times a second. So the total amount of data that's produced is enormous. Fortunately, almost all of it is completely uninteresting and meaningless. So you have to build the technology into the detector to decide for itself whether a interaction is sufficiently interesting that it should be kept for higher level analysis.
Huh. So you have a built-in like signal threshold that it just ignores everything below that.
Yeah, I would say it's much more than just a signal threshold, but it's more like of a simple kind of image reconstruction algorithm. So you basically see where in the detector all the energy from the collision has flowed, and based on that picture, tells you something about the nature of the interaction. So the most obvious sign that something interesting happened is that the protons, I'll use my hands for a second, the protons are coming in along one dimension. And so the most common kind of interaction that can happen is they just kind of have a glancing blow and they fly off in like almost but not quite the same direction that they started. Generally, we're not that interested in these kinds of events. Some people are really interested in those kinds of events for very specific reasons. But generally, the main signal that something potentially interesting happens is if lots of particles are produced perpendicular to the direction of the initial flight. That tells you that there was a lot of momentum exchanged in the interaction and potentially that new heavy particles were generated. So there are other ways of doing it. The name of my experiment, CMS, stands for compact muon solenoid, and that's because muons are only rarely produced in proton collisions. So the mere fact that there would be a muon in the collision is a pretty good indication that you might want to look in more detail at that collision. And it turns out that for technical reasons, muons are one of the easier things to actually identify. Muons penetrate through material much more easily than most other subatomic particles. And so basically by just putting a bunch of metal in between the collision and you can screen out everything except the muons. And then it's such an important way of triggering the experiment that we put it right in the name. And then eventually all of that data, if it passes a couple different levels of triggering, that's what this process of determining whether or not you're going to keep the event is called triggering the experiment. And there's first hardware triggers where it's built into like custom electronics that we build, and then it goes into software for a higher level trigger, which is more capable, right? It's easier to write new software than it is to build new hardware. And then eventually, if it's really interesting, someday, like a graduate student might actually look at it, right? It might pass the selection that they have in their, PhD analysis that they're writing for their PhD thesis, that this event will have made it through all those layers of selection to actually become like a data point in someone's plot. Some famous discoveries in particle physics come from just like one event that's so spectacular that it totally proves the existence of a new particle.
Texas, welcome back. We have with us today is Dr. Ted Kolberg, who's an expert in high-energy particle physics, the Large Hadron Collider, measuring, smashing things in together really, really fast while playing Zelda: A Link to the Past. Are we making progress? Like it might be time for
a change, anyways, right? We have a number of different games that we want to play.
That's true.
I think I've proved that I don't really understand this game.
So sorry if you were showing up for expert level Zelda. It's not happening tonight, ladies and gentlemen. Instead, you're ready to move on to the next one?
Yeah, let's play some Metroid II, The Return of Samus.
All right, we are jumping back in time even further, ladies and gentlemen. All right. So this is for Game Boy 2, Metroid 2. Metroid 1 came out for the Nintendo, Metroid 2 came out for the Game Boy. So black and white, square pictures. Texas Space Agency. I'm a lowly knuckle-dragging economist that also does blacksmithing on stream, actually.
Wow.
So I don't know if you're familiar with Twitch, but it's known for video games, but it also has musicians and technical experts and craftsmen.
I looked at it earlier, and there was a girl playing the guitar, and I was like, okay, I guess they're branching out.
Yeah. So Texas Space Agency also does blacksmithing on stream.
Cool.
It's kind of fun, yeah. This is a subject I will forever be a spectator in. No worries. It's fun to talk about smashing particles together. So yeah, if anyone has any questions about high energy particle physics.
It's fun to talk about these big picture questions because actually we spend approximately zero time talking about them in the course of actually doing research. Actually, a lot of the research questions that I answer are much more pedestrian and will be like, here's like a plastic that I want to put in my detector. Like, what happens if you put it in a minus 30 degree refrigerator? Does it crack? Does it split? What happens if it's irradiated? Like, you take it to a hospital or a university radiation lab and like put a bunch of radiation on it and see what happens. Like, does it turn into a black gunk that then is like a radiation hazard, or does it continue gracefully doing its job of detecting particles? A lot of the time it's like, we do our jobs in really big collaborations. So like, I have a project going right now where we're trying to get Russia and Ukraine to work together to provide two components for the same detector. And like, one of those countries might soon be invading the other. So that's not a problem I can really solve, but it's definitely something I have to be aware of in order to do a good job of managing my project. So a lot of the time this, yes, you're aware in the background that the point of everything you're doing is to answer these big picture questions, but a lot of it is much more practical, real world knowledge.
I'm going to do a shameless plug for materials science, chemistry, engineering, is that all of our progress in every single domain is fundamentally limited by the materials we can make and the properties they have. Like everything from music to particle accelerators to rockets. It's just like...
Yeah, do you have any good ideas for solving the semiconductor shortage? Because that's another thing that really affects our... all the stuff that we build, all these detectors, whatever, it all has custom chips. Which we have to design to do our specific jobs. It's not like you can go to Alibaba and like order a particle detector readout chip, right? You have to design it yourself. And we do a lot to try to reuse other people's work and do common projects, right? So at the LHC, there are many different detector technologies in use, but we try to identify some common components that we can use in all of them so that we can help spread the cost and the risk among multiple experiments.
So how does that work? So you design a circuit board and you have somebody print that? Like it's all specialty designed?
Yes. So like in the detector project that I'm working on, the PCB design is being done by some of my good friends and colleagues in Germany at their big particle physics national lab. But then those designs will be shared with physicists here in the US, and we will produce some fraction of the overall boards that we need here in the US for our own part of the detector that we're building. So there's lots of, the collaboration is like order of 3,000 people, and then the individual detector projects might be, a few hundred or something in each of those. And then what you do is try to divide up the responsibilities according to everybody's own unique expertise and what they can bring to the table. So like what my lab is mostly doing is providing, in addition to analyzing the data and looking for new particles and stuff, we're building this thing which is called a motherboard for our detector, which basically means it's the part that aggregates all of the data from like a section of the detector and uses some intelligence to reduce it down to a more manageable volume and then send it off to the off-detector electronics, these like trigger electronics, for example, for a decision. And so we are totally exposed to the risk that if there's continued supply chain shortages in like semiconductors, right, the reason people can't get cars and stuff like that right now also affects us. And you'll notice that there's a lot of talk in like politics or whatever nowadays about like, should we invest more as a country in having, because all this stuff is done basically in Taiwan, Japan, South Korea. there's some development that happens in the US, but not the really big foundries that make like high volume production, and not the foundries that do, you know, the transistor sizes are down to like 3 nanometers now, right? That's like the chip in your new iPhone or whatever is made with this very, very small feature size. And like we simply couldn't supply that with facilities that exist in the US. It takes years and billions of dollars to generate the ability to work with that kind of technology. So should we invest more in doing it on our own shores? Well, you know, it would solve some problems, but, you know, there's a finite amount of money out there to spend on things, you know. So those are absolutely the kinds of questions that we are always thinking about in my field. Like, it's one thing to design something, but if you can't build it, how good is your design really?
Yeah. Well, the other consideration is cost, right? Where do you get the money for that, and how much money do you have?
Yeah, I mean, for a sense of scale, it's kind of a daft comparison, right? But you know, the whole LHC program doesn't cost that much compared to like an F-22, right? I mean, those things are like billions of dollars each.
Yeah, no.
Who's to say what's more valuable?
So I gave a talk when I was at UNC Chapel Hill for my postdoc. I gave a talk at a bar, like the Bar Science Cafe events. Mm-hmm. And one of the things I talked about was I was part of an Energy Frontiers Research Center that was a $20 million effort across, you know, like 30 people doing research on water splitting and stuff. But I did a similar breakdown.
Water splitting, like electrolysis?
Yeah, like electrolysis, but trying to drive it with light. So if you can do it with light, you can do a solar-powered hydrogen generation cell, basically.
What energy of light do you need to do that? What's the like bond energy that you're breaking?
So we usually use visible light, right? So with 300 to 700 nanometers is the target region. I don't know the actual bond energy because there's so many overpotentials or activation barriers that you essentially have to use double the energy to actually break those bonds and make new ones. But yeah, it's a really fun project. But when I was giving that talk, I did a breakdown about, you know, here's how much the Manhattan Project costs. Here's how much the war on drugs has cost. Here's how much an F-35 costs. Like, it's so negligible compared to those things we invest in. It's just
of course, the numbers are kind of like incommensurate, right? If particle physics offered a way to possibly like guarantee the lives and freedoms of American citizens against like active attack by an external enemy, like, all kinds of things would be different, right?
Yeah. No, it's true. There's a cost benefit, and there's intangibles that, you know, well, also the psychological aspect of it, whether it's, I don't know, legitimate concerns or not. You can't convince the average person that a particle accelerator is going to change their life, because the reality is it probably won't. It'll change their grandkids' lives. So, yeah, it's a tough sell.
Yeah, I mean, you didn't get the light bulb by trying to improve on the candle, right? So you definitely, there's a role for basic research, but I wouldn't say this in like an agency review or whatever, but I think also like there's some value to like being part of the kind of like a culture that like does things like this like, at all, right? Like basically my like politics is based on Star Trek: The Next Generation. Like whatever policy brings us closer to like that world is the one that I'm like likely to support. And I think doing stuff like the LHC definitely fits under that heading. Like it as a statement about like what we as humans like value, what's important to us, and what we're willing to spend our time doing. I think it's a very like positive kind of effort to be a part of.
And there was an awesome like Ask Reddit thread. It was which fictional character would you like to be president of the United States? And the top answer was Jean-Luc Picard.
Isn't he a French citizen though? I guess we don't have like citizenship anymore.
I don't think we're not going to restrict it to those, but just in terms of demeanor and mentality and leadership role, I want to see that guy give a State of the Union address, you know?
Yeah. But I forget what we were originally talking about that brought up. I was talking about what kinds of activities I'm doing at work a lot. And one of the other things that I'm sure all of us in science spend a huge amount of time doing and probably don't talk about enough is like mentorship and training of young people. I think that the people in some ways are the most valuable resource that we produce, more valuable probably to society than any individual detector or any individual paper we would write, is that we create workforce which has, I think, a unique approach to problem solving and a unique like cross section of skills. You know, someone coming from my lab might know a little bit of something about plastics and a little bit of something about semiconductors and a little bit of something about machine learning, and like it's just a unique kind of training that isn't produced by that many different. There's not that many fields that train people in all those things. And, our graduates are in pretty high demand. I guess everyone's in high demand these days, but our graduates tend to be very successful even when they, maybe especially when they leave the field. There are a lot of famous particle physicists on Wall Street and in medical device technologies and all these things, just because the specific approach to problem solving just turns out to be really useful for a broad class of problems outside of physics.
Non-dairy neutrino had a follow-up. Yeah, I've heard a lot of government funding is currently going towards condensed matter research for potential weapons application. It is underappreciated that there is a large chunk of the Department of Defense's budget that goes towards basic research. And not just like build a bomb, but like very fundamental things that in your proposal you have to write how this might be relevant to the military, blah, blah, blah. But in reality, most of it won't be. And so there's a lot of foundational stuff that is funded by the Department of Defense.
I think the barrier between applied and fundamental research is a lot more permeable than most people realize, right? I mean, a lot of fundamental discoveries in science came out of what people thought at the time was what they thought at the time they were doing like practical research on some question, and then they end up having like a really fundamental insight into something. One of the issues, I won't call it a problem, but it's just an inherent issue of having these long projects that take so long to get off the ground and stuff, is that your ability to react midstream, change the focus of your science because of an unexpected discovery or whatever, that's really limited for us just by the time horizon that everything happens.
As my advisor said, writing because it's cool won't get you the grant. That is true. Shaping your narrative is everything. It's not what you want to write, it's what they want to hear. But you can still do the same research. You just got to package it different ways. You are absolutely right.
I mean, I think it's really interesting that like during the pandemic, for example, there were like established biologists at like big universities, Yale, whatever, like applying to these like FAST grants or whatever, like the funding system is so overwhelmed with the number of people seeking funding and the amount of like legal, Congress like passes laws and then the funding agencies are compelled to like follow those laws to the letter. So it's not like they're bad people, but like it's not a very nimble system. And actually, I think not that well adapted to like the nature of science at this point. If you can specify your whole research program like years ahead, that's pretty much like a death sentence for how innovative and
it's true. It's a catch-22, right?
Yeah.
It's an inherent problem. I mean, and they've expanded it to like you have to have broader impact statements now that says this is how this will impact society, and yeah, it's a mess.
Which all in isolation, they're all like good things, right? Like we should absolutely be thinking about the broader impacts of our research on society, but it adds up.
All right, Non-Dairy Neutrino wants to know, what's the worst professional plot you've seen? I remember I saw one that had a picture-in-picture format, but the small plot could have been overlaid onto the big one as they had the same units and scales.
So here's a funny thing. I don't know if anyone has told this story on your channel before, but some of you may remember this quote-unquote discovery of superluminal neutrinos a few years back. There was a claim by a collaboration coming from a detector in Italy. So basically they make the neutrinos at CERN and then they fire them through the Alps to a detector which is underneath a mountain outside of Rome. And they were trying to measure, it's not what the experiment was originally designed to measure. They were trying to measure something else, but there was a claim that emerged from this experiment that they had timed the arrival of the particles to be faster than the speed of light. The neutrinos were actually moving faster than the speed of light. Long story short, it turned out to be an instrumental effect, not physics. But I think many of us in the field knew that something was amiss when we first saw the plot that purported to suggest that this was the case. So we use this piece of software called Root in our field, which provides like Bicep 2, exactly, that kind of a thing. We use this software package called Root to plot, to do data analysis and to plot the results. And by default, I don't know if they fixed it by now, Root came with this really ugly colors scheme where the background of the plot was this like dirty gray beige color instead of white. The first thing you do when you're like a graduate student is you like change your like logon script to like get rid of this ugly color. But the plot that they had was done like with the default color palette with this ugly like beige brown background, and it like made the whole thing seem like instantly suspicious because like they are claiming to have discovered like physics beyond the standard model, but they don't have their like root logon.c macro. It just beggars belief. Right?
Amateur art. That sucks.
And indeed, it turned out to be bullshit.
Wow, that was foreshadowing for incompetence. That's amazing.
Well, what you learn, I feel like when you're a kid, they tell you that like, you know, don't judge a book by its cover, like, you know, appearances aren't reality, and like that's true in like a moral sense, but actually if you get like a paper draft from someone and it's all like messy and the paper's all crumpled up and there's like coffee stains on it, like you're gonna start to think like, yeah, maybe this guy doesn't really have his act together.
Yeah.
And often it's true, right? I mean, like paying attention to the details, including the details of presentation, is actually No. Oh, yeah.
Yeah. First impressions are important, but not the whole story. I agree. It's not an absolute thing, but it's a general rule of thumb. Yeah.
It's just if someone's ignoring the like easy wins that come from making a nicely formatted plot, it could mean that they're like such a genius brain that they can't be bothered with such like quotidian concerns. But it might also mean that they cut corners in like other things as well.
Yeah.
In this case, it was kind of the latter.
Man, that's really fun. So that was retracted then? It was just
I would have to refresh my memory if this claim was. I don't even think it was ever. Probably maybe submitted it to a journal. I don't think it was ever actually published to be retracted. It was like physics by press conference, which like you do that because like your chances to make a big splash and like get in the media are pretty. So this discarded Metroid shell means that there's a Metroid around here somewhere. So I'm gonna get my missiles out.
It's fun.
Yeah, I guess they molt. I can blow myself through this hole with the bombs. Yeah.
Oh yeah, I forgot about that.
This game is pretty obscure. Whoa.
No, but I think you could do that in the original Metroid too.
Yeah, so, you know, people that are willing to cut corners on the easy stuff might also be cutting corners where it matters, right? This is one of the reasons I found that whole, like, Theranos thing so interesting, because that was a case of the opposite, right? Where the person had all of the appearance of being, like, polished. Really what they said that they were and was, like, a great salesperson, but it was all, like, there was no there, right?
Yeah. It's just facade, yep.
So it's tricky.
All right, we're at 9 o'clock. Anyone just joining us? Ask a Scientist Gaming, mediocre gameplay, expert level science. My guest today is Dr. Ted Kolberg, who's an expert in high-energy particle physics. Happy to answer any questions related to that, or Large Hadron Collider, or measuring high-energy particle physics while playing Metroid II for Game Boy. So for those of you that didn't have a Game Boy, this was like one of the first mainstream handheld games.
Through AA batteries like there was no tomorrow.
And what was crazy is it did that without having backlighting to the screen.
No backlighting.
The original Game Boy, you couldn't see in the dark because it didn't have its own light source.
I had like a clip-on like
a light that goes overhead.
Yeah, clipped on so you could like play in bed or whatever.
But like, I remember distinct scenarios where you're trying to play Game Boy in the car at night, and you could only see it under like flashes of light and momentary lighting. But yeah, unlike Game Gear and modern gaming systems, Game Boy was essentially like the modern like Kindle, which it doesn't have a backlight. You can't see things.
They must have a model of Kindle with a backlight now, right?
Yeah, I'm assuming they do.
In
The early
era of
ones,
iPad or whatever.
yeah. The early ones they didn't, but oh yeah, you got the climbing wall skill.
Yeah.
That's fun.
So now I have to remember. I guess I can go back to the top.
All right, so before getting to non-dairy neutrinos question, we should probably do another prediction.
All right. Let's do the first one on the list. I think this is interesting.
Science museum exhibit at this point, which is kind of fun. All right, if you're not following, click the follow button, get your 300 standard internet units. We're going to pop up a question right now in the chat, and you can bet on your answer, which one you think it is. So the question is, cloud chambers were invented to study elementary particles or clouds? Which one of those two
For those
things?
who don't know what I'm talking about here, a cloud chamber is an early kind of particle detector where the energy lost by the particles goes. You basically have like super saturated atmosphere with some kind of vapor, and then the particles going through causes there to be a visible trail. You can see with the naked eye the trail that the particle took through. So many early particle physics experiments were done using this technology.
So there are actually YouTube videos where you can build one of these at home. I've never actually tried. I don't know if you've tried, but...
One of the course I'm teaching right now, a lab course, one of the activities is to build one. It's not that hard. If you have like a Peltier cooler or even some like dry ice or whatever and like that alcohol, it's
there he is.
Yeah, it's something you can do. So this is like the Metroids get like scarier and bigger as you go through the game. That guy was a pushover.
Yeah, that wasn't bad. All right, so you have about 45 seconds. The question is, cloud chambers were originally invented to study clouds or elementary particles. Which one? I don't know the history of this, but this feels like an accidental discovery to me, but I could be wrong on that.
Spoiler alert.
No, I'm just doing intuition. I'm not cheating.
Yeah, I feel like if you're a student of psychology, you can see where some of these questions are going.
Yeah, well, that's the hard part of writing some of these, because there's a meta information associated with it. Like, why would he ask if it wasn't? But,
yeah, but I'm not really trying to bamboozle anybody.
Yeah.
Like
and well, they have to play game theory too. What do they know about you? This is very Princess Bride. Like, did you put the poison in my cup?
Some people watch me know a lot about me. I think most people don't know anything.
All right, so the question was, cloud chambers were originally invented to study what? Clouds or elementary particles? Ted, what is the answer?
That was dispiriting.
Oh.
The answer is clouds, actually.
Oh, wow.
The guy was trying to study... So now we have this modern idea of cloud formation, which is that there's like little dust particles, whatever, in the upper atmosphere, and then there's water vapor up there, and the dust particles produce like a place for these bubbles to like nucleate around, right? Just like in chemistry, you put like a boiling chip in your beaker or whatever, and then the bubbles come preferentially from that spot. Same thing with cloud formation. Like if you have a little piece of dust in the air or something, or even like the ions which are created by the passage of a charged particle, it will nucleate these like bubble sites to form. So the guy was like Scottish, I think. They have long experience with clouds in Scotland, and he was like wanting to test this theory. So his idea was, I'll build a chamber that in my lab that I can charge with vapor, and then I'll spray different kinds of like dusts or whatever in there and try to verify this idea that that this is the phenomenon of how clouds form. But then when he put his like chamber online, he started seeing all these little lines going through, and he's like, "What are these lines? Like, it's nothing that I'm putting in the lab." And it wasn't really understood at first. But what people eventually came to realize is that there's a flux of elementary particles like passing through us all the time. Oh, that just recharges my energy. I thought it was going to be more exciting. Now we would know that they come from... I don't think there's anything more up there. Now we would know that they come from... Well, we actually still don't know where the very highest energy ones are generated. But every time there's like a supernova or like the merger of giant black holes or whatever, there's the potential for very high energy particles to be emitted. And then these particles can travel across like galactic or even intergalactic distances before they finally, by chance, like intersect with the Earth. And that's what those particles were that you were seeing. So there's basically giant particle accelerators in the sky going all the time, these supernova explosions, whatever. And you can see those particles going through. Like if we put a cloud chamber right on the desk here while we were talking, there would be particles going through it.
Yeah, so if you go to a science museum that has one of these set up, typically they'll add some kind of like radioactive isotope that actually generates particles to induce the image, because it's fairly rare that you'd see something, right?
I mean, we have in the department a small one that's like a few inches in diameter, and you'll see the occasional cosmic ray going through, I don't know, once a minute or something like that, order of magnitude. But yeah, if you put a radioactive source near it, and you can actually visually see the difference between different kinds of radioactive sources, right? So there's like alpha, beta, gamma rays that come from different elements, and you can visually tell the difference between those different kinds by the types of tracks that they leave in the particle chamber. Actually, if you go to a library at a university or something, you can find these books from the 30s, 40s, 50s, which are for training students in particle physics. And they just have like page after page they're like coffee table books kind of. They have page after page of these high resolution, not high resolution, but good quality photographs of like what different particles look like in their interaction with like cloud chambers. There's bubble chambers, which is the same idea, but using a liquid instead of a gas. And also then these photographic emulsions, right? So like the Curies or whatever noticed radioactivity because they literally just like put some uranium in a drawer with some like photographic film that they were using to take pictures. And then when they took it out, there was like a dark spot like burned on the film by the radioactive source. So yeah, these were totally accidental discoveries.
So Neutrino has follow-up. Wait, was he filling the chamber with xenon or was it argon? What was the original chamber filled with?
Water vapor.
It was just water. Vapor. That was it. Huh.
Yeah. I mean, it turns out that using like heavier gases, so the heavier the gas, the more energy the particles lose going through.
Yeah.
So you might use a heavier gas for that reason. I think, I don't know, once they were building like really large ones specifically for particle physics, I think they were using like hydrocarbons a lot of the time. It's not really my area of expertise. We don't do it so much anymore. But missiles.
So Ted, I'll have to show you this. So here's the betting outcomes from Twitch. So as 3 people said elementary particle, 1 said clouds. The 3 that bet elementary particles was 1.4K standard internet units versus 10. That was 143 to 1 payout. 2. Maximum Minimus, congratulations on your 143 to 1 return by guessing it was built for clouds.
Wow.
Congratulations. Sorry for anyone that didn't get that.
So now Maximinius can like go buy a bunch of predictions from some other streamer. So they're only good on this channel.
They're only good on this channel, so they can like unlock our emotes, they can make us take a drink, they can request a factoid. Or they can just brag that they got 143 to 1 payout, because that, you earned it. Cheers.
Maximinius should request a factoid. We haven't.
You should spend your standard internet. Non-dairy Neutrino has redeemed Take a Drink. Ted, cheers. Thank you for coming by and joining me to play some Metroid while talking some science. And yeah, congratulations again to those that said, well, the one person that bet 10 points on clouds. Congratulations. Maximinus has redeemed request a factoid.
All right. So you'll have to stop me if you've heard this one before, but...
no, we'll do it.
So I was looking up factoids to do on the stream, and then I became curious about the word factoid itself.
Oh no, we're going meta?
What's the difference between a fact and a factoid, right? Like the molar mass of water is like 18 grams, but that's not a factoid, I don't think. It's just a fact, right? A factoid is supposed to be like unusual or surprising or something. Or maybe funny or memorable. Or
that's the formal definition?
Like if I just said like my car is like, X feet long, like that's not a factoid, right? But actually, so the word factoid was coined by Norman Mailer in a book in the 70s. And actually, he was using it, it's kind of the opposite of what we do now. It was closer to, Stephen Kolberg had this coinage truthiness to describe something which seems like it could be true, but isn't necessarily. Oh, and that's actually what Norman Mailer used the term factoid. He was talking about, like, the industry of people writing, like, biographies of celebrities, where they'll just include, like, a fact that might be like too good to actually check to see if it's really true or not.
Yeah.
That was the original coinage of factoid. It's something that's not actually true, but sounds like it could be.
Oh, man.
So that's kind of like, I don't know, Schrodinger's factoid or whatever, a meta factoid about factoids.
You have ruined our use of factoids, actually.
Well, I think the usage you're using is perfectly well accepted now, but I just thought that was an interesting bit of etymology.
That may be my favorite factoid on Ask a Scientist Gaming. He went meta. Maximus Minimus, I hope your money was well spent on that factoid. Like rhomboids and groupoids. I don't know what a groupoid is.
What's a groupoid?
Metroids.
So yeah, it's the same. That's why it means, so like oid in Greek, right? It means something which like looks like something else. Right? So when you say like humanoid would be something that has the shape of a human but isn't actually a human, or like a asteroid, right? Aster is a star. So people call it an asteroid because a shooting star looks like a star, but it's not actually, it's a rock, right? So factoid, by analogy with these other terms, is something that looks like a fact but isn't.
Yeah, that makes sense. Synegus, I'm sorry. Small-brained right there. RIP me. First time in the chat has lost money on a prediction. I apologize. But you did learn something today, both about cloud chambers and about the definition of factoids. So it was well worth all money spent. So thank you for stopping by and betting your points on that question.
If you don't like the factoid, you're entitled to a full refund.
Exactly. Write an angry letter to Twitch and tell them you don't like predictions. Oh man, that is really fun. I better try my luck at the casino. No, that wasn't luck. You knew it was to study clouds. But that was one of the meta questions. Like, why would you ask that unless the answer was not the obvious answer? But
so I'm realizing as I play this game that the next game that we want to play is basically just like a better version of this game. It's like more fun and colorful. It has like some really bitchin' tunes. And so I'm going to propose that we switch over to VVVVV, which is the next game I had on the list, right? We're getting towards the halfway point, I guess, here.
Yeah, we're at 9:16, so might as well. Let me close this guy up.
Plus, I can stop holding this horribly non-ergonomic original Nintendo controller. Can you imagine kids for like years like sitting?
Show the camera that for those of you that didn't play on original Nintendo controller, it was a crippler, and like our hands are bigger now, so it hurts even more. So yeah, let's go.
Who thought that this would be comfortable to hold? This rectangular prism.
No one thought that at any point.
Compare, like this is the PlayStation 5 controller, right? My hands are happy just like looking at this thing.
It's ergonomic.
It's nicely textured.
All right, so is your PlayStation 5 on? By the way, we figured out how to get PlayStation 4 and 5 to work with our capture card, so...
she's stirring to life.
All right, no worries. You can play Metroid in the background right now if you want. Factoid. What do you mean your hands aren't rectangular? Hey, I am not a kinesiologist. I don't understand this biology stuff. All right, it's warming up. There you go.
There we go.
All right, ladies and gentlemen, we are transitioning to PlayStation 5, but playing an Atari-like game on PlayStation 5.
Yeah, when I first played this game in grad school, I don't know how old it was at that point, so it's probably like 10
so I looked up
years
old. I looked up the origin date, and it's 2010. So this looks older.
A little more than 10 years old.
Yeah.
I got my PhD in 2011, so that all tracks. The idea of this game is that it's a platform game, kind of like Mario or kind of like Metroid, where you explore a world, but you can't jump, but you can like reverse the flow of gravity. So you can fall, and you can change, like when you press what would normally be the jump button, you'll see.
Oof. That's some volume. Sorry about that. We did not set up the volume for this system, but now we should be good. Let me know if that's okay or if it's too loud or not. By the way, note that this is being played on a super powerhouse PlayStation 5.
I should be like mining cryptocurrency on my PS5 while I play this, because I'm pretty sure it's not fully...
Can you run this on a TI-85? Probably.
Maybe. Although one of the great things about this game is when you finish this game, it tells you how many times you died. And for me, if we played it all the way through, that number would probably be in the thousands. It's like a hard game, but forgiving in the sense that you like immediately, so he can't jump, but he can fall upwards.
Yeah.
But as soon as you die, it just immediately, without any delay, respawns you right back at the last checkpoint, which is usually in the same room where you died. So even though it's hard, it just gives you a chance to repeat as many times as you need.
So I looked it up. This came out at about the same time as Super Meat Boy. I don't know if you've seen Super Meat Boy, but
I have. I'm not that much of a glutton of punishment to have actually played it.
I mean, it's a similar concept, right? It's just I don't know how much more difficult it is, but yeah.
Almost everyone has been evacuated from the space station now. The rest of us are leaving in a couple of days once our research has been completed. Research? That's ominous. Linear Collider, look at that. The level names are really fun too. Sometimes he kind of hints you what you're supposed to need to do based on the name. I don't know how many like screens there are in the game. It's got to be hundreds, but they all have these unique and creative names.
So have you looked up a speedrun of this game?
No, I'm sure it's really embarrassing to see how fast. I mean, because there's not like, if you know exactly where you're going, a lot of it is exploring around to find where you have to go next.
So there's a couple different categories. I found the fastest speedrun, they actually figure out how to write to RAM and get it to go to end credits right away. It takes 30 seconds.
By some combination of button presses?
Yeah. Like, and some saving and reloading and all sorts of crazy things.
Those always seem like cheating to me. I want to see someone actually play the game as fast as they can.
But have you seen the Super Mario World one where they like position things and write to RAM and execute and they can get to it? Like, it's impressive that they come up with it, but I agree. It's not
like the art of the, like, is it Donkey Kong or something that ends in these, maybe it's Pac-Man that ends with these, like, after you get to level 255, it's unpredictable, depends on the state of memory, like what happens next. And you can get a few more points if you're lucky enough to like spawn in an area where there's some like dots to eat or whatever.
The original, the kill screens. But the normal inbounds gameplay, apparently you can go out of bounds in this somehow, but inbounds it's something like 12 to 15 minutes, something like that for the speed run. So I always look it up just because I'm curious, and then it makes me depressed and not want to play the game because they've already broken it. But so it goes.
Yeah, I looked up, I guess we'll talk about NARC later, but I looked up the NARC speed run that holds the world record. Somehow I thought it might have been you, but it's not you, it's some other guy, right?
Should I reveal that now or save that for later?
Let's save it for later.
We'll save it for NARC.
Okay.
But the short answer is yes, it is me. I'm the record holder.
Oh, you are?
But that's my gamer tag. And not my... I won't use my normal name when playing games.
I see,
so,
okay.
Yeah. But, yeah.
Well, congratulations.
I kinda. You know, it's a little victory. I'll take it. It started as a running joke. But.
Tom Bissell, who used to write for... he used to review video games for some things. He's a novelist, too. He had the quote, "There's only one other activity in life I would less like to see an audit of how many hours I've spent doing than playing video games."
I mean, but it's quality of life. Like, I don't regret any of the moments I played on video games.
I regret some of them.
No, so some of the games. No, you're right. Like, if you've ever played, like, Superman for the Nintendo 64, yes, you probably regret that.
Yeah, that kind of a thing. Or, I just remember when I was a kid, you would go to, like, Blockbuster Video and rent games, and so many of them were just terrible. They would be, like, cash-in things for, like, big, like, 90s Blockbusters.
Yeah,
right? It's like, oh, we gotta have a game to go with, like, whatever, Kevin Costner's Waterworld or whatever needs, like, a game.
Or E.T., the original Atari failure. Yep. No, you're exactly right. And the thing is, you didn't know. You didn't have the internet to look it up ahead of time. So you looked at the cover art on the box, and you're like, that looks like a fun game. And it's just
Kevin
terrible.
Costner, I'll
exactly.
slap his name on anything, I'll buy it.
Yeah. All right, we have a few questions to catch up on. So what is Ted's specific research? What do you do? What are you looking at specifically?
Yeah, so we talked a little bit about the detector stuff that I do. So the detector that I'm working on is called HGCal. Whoa. HGCal, which stands for High Granularity Calorimeter, and the basic idea is, so the existing calorimeter that we have right now in CMS has like tens of thousands of channels. So if you want to think in terms of like the resolution of the picture that we're creating of the particles, it would be like tens of thousands of...
So can you switch back mid-jump?
Nope.
Okay, so
No,
it's
once you jump, you're
unidirectional.
committed.
Oh, wow, and so you have to direct it from there, okay.
It gets really gnarly later on. There's like you're like flying through whole screens. Anyways, so the basic idea of the detector design that I'm working on now, is to increase this from like tens of thousands to tens of millions. So we would take a leap in the like megapixels of our camera or whatever of like several orders of magnitude. So I work on developing the materials and the electronics to operate that detector. So now you can just die and go back to the checkpoint. That's one nice thing about this game. Oh, I have to do it again.
No.
And part of my job on that is also, as boring and unscientific as it sounds, is project management. So we have these big projects that are made up of dozens and hundreds of people in all these different countries, all with their own funding agencies and stuff. And like somebody needs to actually like coordinate all that effort and make sure that everybody gets this like stuff that they need and like no one goes to jail for like misappropriating research funding or whatever. So I spend some time like managing that project, meaning like doing paperwork for the government to make sure that the money is being spent like correctly. And I contribute scientifically as well. And then my analysis work, so we haven't mentioned yet the Higgs Boson on this stream as obviously one of the biggest and most important discoveries in particle physics recently. And Higgs Boson has a special property that it couples to other particles, we think, based on how massive those particles are. So you may have heard the idea that the Higgs Boson is responsible for generating the mass of the other particles. And that's kind of the same idea as what I'm trying to say, that like the Higgs boson, if there are new heavy particles that we haven't discovered yet, it's likely that the Higgs boson should also couple to them because they're massive. If we're right about the role that the Higgs plays in nature, then that's likely to be true. So what... I need to get down there. What I'm interested in is the possibility that the Higgs is actually decaying to new particles that we haven't discovered yet, but that we haven't been sensitive to the discovery because the new particles have some quality that makes them difficult to see with the detector that we've built. So I mentioned how it's hard to be really nimble with your research when it takes decades to propose and build and operate an experiment. And I'm trying to kind of mitigate the impact of that by looking for novel ways that we can use the detector we already have to search for types of particles that the people who originally built it were never considering. In particular, what I'm interested in is the possibility, so all of the new particles that we've discovered in the last few decades almost all have extremely short lifetimes. So the Higgs boson and the top quark, I don't think there's any way for me to get under there. The Higgs boson and the top quark and these other heavy particles that we've discovered recently, they basically, they decay so quickly that for the purposes of the detector, they might as well not have a lifetime at all. That it looks like they are just produced and immediately decay. The distance that it takes for them to fly before they decay is so small that we can't resolve it with current technologies. As a result, the experiments are heavily optimized to look for particles that are decaying as soon as they're produced. But it could be that new physics actually manifests as particles which have a non-zero lifetime, like something that is actually significant on the scale of our detector. And if that would be the case, then a lot of the strategies, the software, the hardware that we use wouldn't really be applicable anymore. So we have to think of clever ways to kind of break the way that the detector functions, like use the detector to do things that it wasn't originally designed to do. So this might mean writing new software that's different than the kind of default software which is used to reconstruct the collisions. But it also might mean like looking at data sources, data streams that people were only collecting for other purposes in case they contain these like rare and unknown types of events. So it's interesting because it forces you to examine your assumptions of what new physics would look like and to be a little more creative in thinking of the scenarios that you might be looking for. Now, when I started doing this maybe about 7 or 8 years ago, we were kind of like a strange band of cowboys like doing this stuff, but it's become rather trendy in the meantime, which is good because I think the physics is worth doing, but a little bit of that appeal of like going off the beaten path has been lost and it's become somewhat more mainstream. But I guess that means that the research program is like appealing to people and people think that what we're doing is a good idea. So I'm happy to see other people joining the pirate ship.
I mean, that's an interesting cost benefit because like you want to pursue it and it's your initial thing, but also you want others to do it too because you want to solve problems. That's kind of fun.
Yeah, when I was younger, I would have worried more about people like stealing your thunder or whatever, but like physics is big enough for all of us.
Well, I mean, you have 100 author papers regularly. Like, it's not...
Oh, I don't know if I have any papers that have fewer than 100 authors. Almost all of my publications have the full CMS author list, which is 3,000 people. I mean, it takes like 15 typeset pages just for the author list.
Yeah.
They don't even like publish it in the journal, right? Like PRL, they're not going to spend 15 pages just for an author list. So they publish like a supplement you can go download that has the author list.
The next time you're on, that would be a fun prediction. What is the least number of authors on one of Ted's papers? Less than 150 or greater than 150?
I've done some smaller like instrumentation papers. Like we do these things called test beams where you build like a subset of the experiment and expose it to a beam, usually coming from like an older accelerator or like an accelerator line which isn't used for like cutting edge research, and those papers might have a few dozen authors. I have a few of those, but almost all of my publications are. So I was saying at the beginning of the stream, you know, I'm going to be an associate professor starting in the fall, which means I just went through this tenure process, and one of the things you do for that process is like list all of your papers, and then they say produce like a summary of like what you did for this paper. And I mean, I have contributed to all of them in some very abstract sense that I've like helped to like design and build and operate the detector. But if I'm being honest, like what fraction of those papers have I actually read is not high, right? I mean, some of them I'm assigned to review as part of my like work for the collaboration. You are on these like committees where you help other people get their analyses approved, which is also a really useful job that somebody has to do. But you know, I kind of think in terms of PhD students. So I've had one PhD student graduate since I was here. So his thesis analysis is actually, he graduated in December of 2020. We're still dealing with the referee comments on the paper based on that work, but it should be resolved soon. It's just the publication model is an awkward fit for our field at this point.
Well, I was going to say, doesn't that kind of negate the idea of like number of publications or citations, H-index, that kind of becomes meaningless?
I mean, I have a really good H-index.
I believe it. Number of papers and...
I mean, like the Higgs paper has been cited like tens of thousands of times, right? Just that one paper. And we have some other ones which are really highly cited too. I had to look it up at some point. They don't ask you as part of your tenure binder, but on the same website where you can like generate your publication list, you can look that stuff up.
Yeah, so FSU has this online system. It's FEAS. I don't know what that stands for, but it's the online.
Like PTSD. Just
oh my God! You have to upload it, and they have a request there. They're like, "Could you please highlight the undergrads that were involved with this research?" So, did you do that on your 100-author paper?
No, although I do work with undergrads at FSU a lot. We have really good undergrads at this school, and I always try to have at least a few undergrads working in my lab. It's been a little awkward with the pandemic the last few years, just because a lot of the in-person activity has either been happening kind of off-screen, or you know, you don't want to expose people to danger or whatever. But you know, there's lots of things, because our work is kind of interdisciplinary in the sense of requiring so many different like software and hardware skills. There's openings for people to do everything from work with their hands to like writing software and like everything in between. So I think undergrads, I had no idea what real research was like when I was an undergrad until I started doing it, right? Like the movies or whatever don't prepare you that well for the reality of what a modern like research lab looks like. At least I had no real idea, no accurate idea anyways. And boy, did I learn a lot. As an undergrad, there were things that I thought would be really interesting and fun to work on that I hated when I had a taste of it. I started working in this lab working with Bose-Einstein condensates, right? So this is where you trap like a few dozen atoms in like a very small region of space with lasers. And part of this trapping process means that they cool down to such low temperatures that they basically all occupy the same like quantum state. So it's like a group of 50 atoms that are cooled down to almost absolute zero, and it kind of this is what I should have done the first time. It kind of behaves in some ways like one giant particle because they're all so low energy and packed so closely together that it's like a coherent quantum system. Sounds really interesting, right? But the whole game of doing that is you have zillions of tiny mirrors, and you have these lasers, and you've got to really precisely adjust all the mirrors to reflect the lasers in exactly the right direction. And then when you get it adjusted just right, you have to put a little dab of Loctite, like that you would buy from the hardware store to prevent a screw from coming loose. And you don't, once you adjust the mirror, you want it to stay there. So then you gotta like try to dab this Loctite on the little adjustment screw. But sometimes like just the act of like dabbing it on there is enough to like disturb the mirror, and then you have to start all over again. And you might have a box that has like 4 dozen of these mirrors you have to go through this process with just to get the laser beam like around a corner or whatever, you know? So sounds really cool, conceptually really cool. It made me want to tear my hair out working in that lab. And I was really happy to do something else. And then I worked in the astrophysics lab for a while, solar physics actually. So we were measuring the vibration of the sun. So the sun is like a giant ball of fluid. It is a giant ball of fluid, which means that it vibrates. You know, it's hanging in space, and so it vibrates all these different spherical harmonics, right? Which is if you try to wrap like a sine wave around the surface of a sphere, you get these functions called the spherical harmonics. And when there's a disturbance on the surface of the sun, like a sunspot or a region of high magnetic field activity, you can sense this because it changes slightly the vibrational frequencies that the sun is vibrating at. So you can actually calculate what the opposite side of the sun looks like from us and predict if there are like sunspots there, which is a huge economic value because sunspots drive like power outages. Like the military lives in fear of sunspots because they have all of these high, you know, a modern fighter plane without its like suite of like satellites and stuff that it's communicating with is much less useful. So if a big solar storm went through at the same moment that we're trying to start a war or something, this would really, you know, cramp their style. Anyways, again, really interesting, enjoyed the research, but I found it bothersome, the idea that you spend years of your life to build this satellite, and then you launch it, and if there's like a screw loose, that's it. You can never go. Like the Hubble, at huge expense, they mounted this like one mission to go access it and fix this problem with the mirror, right? Yep. But in general, it's just literally you're launching it into space, so it's just gone. Yeah. And that bothered me that like really you can't fix it. You can't go in there and like tighten something. You can't like unsolder the resistor and replace it with like a 10K resistor if that's what you turned out to have needed. I found it like conceptually bothersome. As it turns out, the LHC experiments aren't that much different. Our opportunities to access the experiments are few and far between, but we can definitely interact with them in a much more meaningful way.
It's not in space. That's a plus. Yeah. Non-dairy neutrino. Yeah, that's why I'm not an experimentalist. Computational gang represent. I mean, it's no joke. If you're an experimentalist, whether it's physics, chemistry, biology, you are an electrician, you are a plumber, you are a carpenter. You have to do all of it because it's all going to come up at some point. So, yeah, heads up for any prospective grad students. It's.
I feel like I'm always looking for a drill. I'm like, where's the drill?
Yeah, the toolbox. That was one of the first things I bought as a professor.
Something. Yep, exactly. Yeah, me too. Like
the set of screws.
Standard, like Stanley, like big. It's like the trifold big toolbox.
Yep.
Screwdrivers and stuff, and then it immediately all starts to disappear. Right. Yep. I used to think it was so like funny that like old. Like scientists would like tie their screwdrivers to the desk and put like their name on it in like giant yellow paint or whatever. Yeah. No, man, that's very smart. Yep. People will just walk off with your tools. They're not trying to steal them. It's what happens. All right, so now this game introduced this new mechanic that there's these lines that when I cross them, it's going to switch the direction of gravity.
Oh.
Whether I want to or not.
Yeah, so yeah.
I got to get ready to bounce. It's perfectly safe.
I did see this.
This is where this game starts to kind of like achieve liftoff for me, both in terms of the soundtrack, which again is just like kicking, and also like it's just so wild.
Is the volume appropriate for you to jam to VVVVV? Let me know. Give me Mathematica, a nice keyboard, a comfy chair, and I'm set. Yes, theoreticians, you have the life.
Oh boy. Okay.
Wow.
Solvable problem, I think.
What do the vertical lines do?
Same thing. So I need to start in the opposite direction that I want to go, right? Because this.
Oh, wow. Look at that.
Okay, and now I need to flip off this one.
Nice. Veteran.
Hey, that was good.
Yeah.
Even I'm happy about that.
Oh, now you have to go back.
Young man, it's worth the challenge. I like too that they just call it a tiny, shiny trinket. There's no like pretense that it's like it doesn't give you more hit points or anything.
Man.
It's just purely for the lulz, as the kids say.
What I love about this game is it perfectly exemplifies that it's not the graphics that make games fun. It's the gameplay, and it's
I think
really
this game
lost.
would be worse with better graphics.
Yeah. Well,
Because it's such a pure elemental challenge, it deserves to have like pure elemental graphics.
Well, there's these franchise games like the like NBA 2K series and a lot of sports games where it's all about just moving the graphics forward incrementally, but the gameplay is fundamentally exactly the same, and they've done nothing to make the gameplay better.
I think I bought like Madden 2017,
Yeah.
and I have not been at all tempted to buy another one. It's like, I get it.
Yeah, no, that's it, right? Do you want it to be prettier? That's what you're buying with the new ones. And I guess if you care about the up-to-date athletes and keeping with trends, but
as someone who like paid for the software, I feel like paying for a glorified roster update is like a pretty abusive business practice.
Yeah, no, I agree.
Yeah, you start getting these like multi-screen puzzles.
All right, speaking of video games, Maximum Minimus wants to know, is there a video game that uses or demonstrates concepts from particle physics?
Oh, good question. Well, I guess it depends how liberal you want to be with your interpretation of what constitutes particle physics. Definitely the concept of like a multiverse is something that I feel like is resonated massively in pop culture, not just in video games, but in like Marvel movies and all that stuff too, right? Like that's what all is. You watch like 4 Disney Plus series of homework before you can go see the next Marvel movie to understand their like take on the multiverse or whatever.
Yeah.
I wouldn't say that's specifically like a particle physics thing. I don't know, the attitude of the Ghostbusters towards their proton packs in the original movie feels very true to me. You know, when they're like, you know, have a chance to test these things properly, and then they're like edging away from him in the
elevator.
That feels like actual science.
Dude.
Also, where he's using his like experiment to try to like hit on the girl in his psychology lab, that also feels like true to life to me, although not particle physics specifically.
Yeah.
That's not a video game, I guess. I don't know. There's lots of like video games that invoke like the concepts of like particle beams to justify some cool, you know, black hole shooting weapon or whatever, but none of it feels particularly well motivated by physics to me. I don't know.
I mean, there's a subset of NSF funding that goes to people trying to develop games that teach science. I know one that was trying to do chemical reactions and mixing something together. I'm sure they've done something similar with particle physics, but
did you ever play Space Chem?
I did not. Was it good?
It's a fun game. It's more like plant engineering than chemistry, really. Maybe chemical engineering. It's like you create, it's one of these like Factorio type games or whatever, where you create like a pipeline to make some product out of like basic resources, but
that's fun.
You're setting up basically you're setting up like, it's supposed to be, I don't know, you're colonizing Mars or something. You need to set up factories to make like all the different emulsifiers and whatnot that like industrial civilization requires. But again, not really particle physics specifically.
Man, this is a non-trivial, like the angle of attack is everything here.
I'm kind of like idly playing while we're talking, so
Yeah.
I'm not quite as bad as it makes me look. But it is a challenging game.
No worries.
This one is abusive because you have to start moving right away
Yeah.
to get it through there, but it takes you a minute to register when you switch. You almost have to just do it by timing.
And it's projectile physics. It's
That's why the music has to be so good, because you end up like solving these. Your muscle memory gets like pegged to the beat of the music.
Yeah. Use those cues. That's really fun. All right. Non-dairy Neutrino wants to know: is the Higgs massive? Does it self-interact? Wait, we should do a prediction because you have one related to this. It's bottom
Yes,
one right here.
there are vertices that you can draw that have multiple Higgs bosons. That was a very technical way of answering the question. Yes.
Should we pop that one up now?
Yeah, that's a good one.
Related to the mass of the Higgs. All right, so we have a weight competition with this question. If you're not following, click the follow button. I missed a follow from someone. I will get to that in a second. We're going to pop a prediction up right now. Use your standard internet units to guess which one of these answers it is. The Higgs boson is the heaviest particle or the second heaviest particles?
Of course, we mean fundamental particles, right? I mean,
Yeah.
like a lead
Not-
atom is like
not
somewhat
rust
heavier
particles.
than the Higgs boson, not hugely.
Of the barrage of fundamental particles, is it the heaviest particle or second heaviest particle? Alpha, thank you for the follow. I apologize for missing that. Hopefully you're still here 22 minutes later, but thank you for the follow. Enjoy your standard internet units. Throw your questions in chat if you have them. Also make a prediction. Is the Higgs boson the heaviest particle or second heaviest? I have a feeling there's a subset of our audience at this point that waits till the last minute to answer the question based on what other people answer. Not just
Well,
for the
that
answer.
can really get you into trouble.
It can, but you can also game it where you do 10 points on a skeptical. Okay. So yeah, is the Higgs boson the heaviest particle or the second heaviest particle? Throw your guesses in there now with your standard internet units.
The noise is so sad.
Mad. So I like watching Super Meat Boy because he explodes when he dies.
He leaves like greasy
Yeah,
streaks over the
exactly.
level while you like wall jumps, right?
Yeah, it's a meat marker. This is what I've heard it described as.
That's truly disgusting. It's the same
But
guy from The
accurate.
Binding of Isaac, right? That guy
Yeah.
turning into like fluids.
Yeah. But it sells. The people love it. That's awesome. The Binding of Isaac. I watch more video games than I play at this point, but nice. It seems pretty generous with the checkpoints, at least.
Yeah, there's usually a checkpoint like right in every dangerous area. I'm trying to decide if I want to. There's something still down there. I think I should fall down there and see. A tantalizing.
All right. It's ended. Only 2 people predicted. They both said it's the second heaviest. Isn't it the heaviest or the second heaviest?
Both people are right. The like sort of larger point that I wanted to make about this question is that because like we have to build high energy colliders to find new particles, it makes it seem like the mass of the particles is this really important thing that we want to know. And it's kind of true for the Higgs. I mean, there's some worlds where if the Higgs was like much heavier than what we now know it to be, it would imply something about like other laws of physics.
Mm-hmm.
But in general, actually, the masses of the particles in physics, we talk about them a lot because it's like a plot of the mass of the particle that you use to make the discovery. But a lot of the time, like the pattern and values of the masses in the standard model actually is something which we really don't understand, like why. So if you look at the standard infographic of the standard model, there's like these 3 families of matter, which are all looking very similar to one another in terms of their like particle content, but they just have like different masses. And even within the families, the relations between the masses of the different family members isn't really the same. But so lots of people are tempted, you get like emails from people who are interested in particle physics that are like members of the general public, and they'll come up with some like formula that relates these masses together or something and think that it's really significant, but it's not really well understood like why particles have the masses that they have. And in some ways, it's kind of like a free parameter of the standard model. Like, it's not that... The Higgs, again, being a partial exception, because there could be some... The mass of the Higgs could tell you about some kinds of physics that might or might not be true. But in general, like, the fact that the top quark has the mass that it has compared to, like, other quarks... you know, how significant is that mass really is a kind of an unknown question. A lot of it just seems kind of random, yes.
Man, that seems like this would be easier on a keyboard. Have you played this on computer?
I originally played it on computer, but I want to say... I don't remember. My roommate in grad school was really into this game. I think he played it on a keyboard.
Huh.
No, as long as you have the D-pad on the controller.
Oh, I suppose you're not using analog.
The analog sticks would be a disaster.
Yeah.
That I certainly agree with.
That makes sense.
I'm sorry. Please forgive me.
I'm just fascinated by this. I haven't seen all these levels. It looks like a lot of fun.
This looks like a pain in the you-know-what. Let's start from the ground.
Massless families are all alike. Every massive family is massive in its own way.
We have the Nabokov devotee in the audience.
That was Maximus Minimus with their 143 to 1 payout. They could pay anything they want.
One of my least favorite things, which is think about what I should do next instead of just reflexively doing it. What is the strategy here? I can kind of see where he has to go, but I'm still unsure which. Okay.
Jeez. It's all about rhythm.
Yeah. I'm gonna get it.
Oh.
Come on.
Yeah, take a drink.
Surprisingly, it's
Take a
actually
drink.
fun.
Cheers. No, it does look like fun. I love these classic. I don't know if you remember early internet, like when Java games first came out, and there was just like entire web pages dedicated to playing these similar games to this. That were just, you know, fun mechanics.
So not only is this like the symbol from an electrical diagram for a diode, kind of like an arrow pointing in the direction, but it's a literal diode in the sense that I can't figure out how you would ever make it through in the opposite direction. The one way to
It's a perfect rectifier.
And it will kill you. So like diode is doing like triple duty as a pun there.
That is awesome. So you saw that the first time and you're like, yes, way to go.
It's one of my friends. It's okay. I'm here to rescue you. Let me explain everything.
Oh yeah, so the original question is the Higgs massive and does it self-interact? So you give it a very technical answer. Is there a layman answer to self-interaction?
It does, although we don't think that the Higgs gives itself mass by the Higgs mechanism, if that makes sense. The mass of the Higgs being massive is a consequence of the role that it has in physics. Like it does what's called breaking the electroweak symmetry. So this means that the weak force, which governs like radioactive decay, and the electromagnetic force that governs like bar magnets and circuits and all those things, like at sufficiently high energies, these two forces look the same. The symmetry between them is broken by the fact that the electromagnetic force is carried by the photon, which is massless, whereas the weak force is carried by the so-called weak vector bosons, W and Z, which are massive. And the Higgs concept was originally invoked to understand to make a dynamical explanation of why this symmetry is broken. So this is coming back to the topic we were discussing at the very beginning of the stream, which is
This is the goal to explore
we try
everything?
to find dynamical explanations where possible. So this gets very technical, and I'm not really the right person to explain it well, especially not at just like a conceptual level without using math. But basically, the Higgs boson its mass is intimately related to the fact that the weak force has massive force carriers and the electromagnetic force doesn't. And what that essentially means is that if a force carrier is massless, like the photon, it can travel arbitrarily far without interacting with anything, right? One can see photons that were emitted like literally billions of years ago, or actually like in the immediate aftermath of the Big Bang, and they have just been sailing through space totally unmolested ever since. But since the weak bosons are so massive, and in fact much more massive than the particles whose decay they regulate, they can only exist in what particle physicists would call like a highly virtual state, meaning that like they can borrow enough energy from like Heisenberg's uncertainty principle to exist for a short time and fly a very short distance, but they can't
We'll take that checkpoint.
Yeah, now this is intense.
Oh wow. Added a time, but it has checkpoints. Oop.
Yeah,
not that one.
You can't just go like balls out speed either.
Yeah.
You have to
gotta execute.
I keep thinking I avoid it whenever possible, but sometimes it's unavoidable.
Oof.
Oh,
Oof.
I'm not going for that. Unfortunately,
Don't be a hero.
I don't even know if you can visit this again after you clear it. Oh,
that's fun. All right.
Sure. Yeah, I'll take another one. So unfortunately, with my PlayStation plugged in here, I can't see the chat. So we'll have to wait for Ken to get back. Patience is the key. So sometimes you'll hear people say this, actually a factoid in the sense of what we were talking about earlier, like a Norman Mailer factoid, that the Higgs is responsible for like the mass of all the matter that you see around you. And that's actually not really true. It's complicated, but most of the mass of like the protons and neutrons that make up your body actually is not generated by the Higgs mechanism, but by the interactions of the particles inside of that thing. So like the proton is made up of quarks and held together by gluons, and it's like the energy of all that stuff interacting inside, which gives the proton and neutron most of their mass. And because of that, because your mass is mostly neutrons and protons, actually not that much of your mass is generated directly by the Higgs mechanism. But it's a good talking point when you want to convince people that the Higgs has some kind of relevance to your daily life, but it's not really true.
Oh, non-dairy neutrino. Has Ted ever played Celeste? Have you seen Celeste and or played it?
I have. I've avoided it because I feel like I learned to play this game during a time in my life when I had way more time to like take on meaningless but extremely difficult and repetitive challenges. Time is almost completely gone now from my life, and so, you know, it looks like a cool game. I know people really like it, but I don't think I would have the time to master it.
Yeah, Neutrino described it as this, but with a jump and a dash.
Yeah,
which seemed
I
pretty
also
accurate.
respect the simplicity here that there's just like one button. I mean, there's a button for the map and to pause, but
Alpha Donovakin says, greetings, Professor Kolberg, from your lab students. So one of your students stopped by.
Welcome.
Class lab or research lab?
I assume class lab. So this semester I'm teaching what our department calls intermediate and advanced labs, but they both use the same structure and the same set of rooms. So I have to remind myself exactly how many, like order of 15 different setups that the students can choose from. Huh. A lot of them revolve around measuring Planck's constant, because that's a really fundamental thing in like modern physics. So various systems where you can demonstrate the quantum nature of light. And we try to keep them all working.
So Alpha, now it's your opportunity to ask Ted questions. So throw them in chat, and it's anonymous. So feel free to ask anything. He will decide whether he wants to answer it or not.
Yeah, the question is, when would lab report 1 be graded? I'm not going to answer that.
And will this be on the test? No, that is banned on Ask a Scientist Gaming. I literally have a rule in the rules of our chat. Let me go down to it. It says... no homework questions, advertisements, or spam. So, no homework questions, but general science questions. Ted is happy to answer those.
Hey, I got another guy.
Are you collecting?
Guy. I think his name is Vermilion. Yeah, you got to get all the V guys.
Oh man, it's almost 10 o'clock. We should do another prediction. Which one do you want to do? You have these 3 left.
Oh, let's do the question about symmetry. Because I think this is interesting. We alluded to this earlier, like what's the technical meaning of symmetry in physics?
All right, if you're not following, click the follow button, get your standard internet units. It is time to gamble on questions and or know the answer and bet on a certain thing if you know it. But Ask a Scientist Gaming honor policy, you don't look up, don't use Google, although I don't know how you would Google this answer actually. But anyway, so the question is, right now, what is more symmetric? Is it liquid water or a snowflake? And so this is, we can conceptually think about this as the traditional definition of symmetry. Is that fair?
Yeah, I mean, think about it how you want. I think it's also like a little bit arguable, but I would tell you the sense in which I would defend the answer that I picked.
That's fair. So yeah, put your predictions in there now. Which one's more symmetric, liquid water or a snowflake? Throw your guesses in there or know the answer and put your answer in accordingly. If you're not following, click the follow button, get your 300 standard internet units that are useless for anything outside of this channel, but fun to win nonetheless. You can ask Maximus Minimus how much power it feels to win that much standard.
So now I have like an escort mission. I have this other guy that is going to follow me around.
And follows the... How does that work?
So you can... He comes when you're on the floor, and he stops when you're on the ceiling. So you can control his...
Oh, jeez. All right.
I don't want him to come here.
Reese's Pieces. If this answer doesn't mention group theory, I'm going to submit an academic appeal to Twitch. That's fair.
I don't think I'm going to mention group theory.
It's fun you mentioned that, Reese's Pieces, because I'm teaching group theory this semester, actually. And we talked about
the chemistry department.
Yeah. So we use it to find like how the structure relates to things like vibrational modes and optical transitions, and it's all related to the symmetry of the molecules. So yeah. If it doesn't, put your predictions in there now. Which is more symmetric, liquid water or a snowflake? Oh, last 10 seconds. We're going to let Ted focus on this because this is...
I forgot this was in this game. It's actually like a way different kind of challenge.
So he always goes, or he just catches up to you?
He'll just go as long as
you're flipped, okay.
I think he'll only come as far as me.
Okay, so it gives you some control there.
This is a chance to deliver some exposition as well.
All right. So it's closed. Which is more symmetric, liquid water or a snowflake?
So I'm curious, first of all, what people said, and I'm curious what you would say, and then I'll give my answer and my justification.
Okay, so here is the betting if you want to see the outcomes. 5 people said snowflake, 1 person said liquid water, 460 to 10 in terms of the amount of betting. And so if it's liquid water, it's a 47 to 1 payout. If it's snowflake, it's a 1.02 to 1 payout.
And what would your answer be?
It's traditional definition of symmetry based on, like, symmetry operations, reflections, rotations. I would say snowflake.
Really?
Yeah.
I mean, the liquid water is like a isotropic fluid, right? If I just have like a vial of water, if I'm at some point inside that vial, like I have no idea like what way is like up or down. I have no idea what way is north or south. I have no idea what's left and right. The fluid around me, unless I get down to the level of the individual molecules, and even then they're completely randomly arranged.
Yeah.
I would say that it's a very symmetric situation. There's basically no experiment I can do, no way to tell any like directionality to that system. So the number of like translations, rotations that I can do and still end up in a situation which is indistinguishable from my starting one. In liquid water, there's a lot more. The snowflake, on the other hand, is symmetric in the sense that there's specific operations I can do, like rotate by 60 degrees that might get me back to something like my starting point. But any rotation like out of plane, right, then I'm immediately in like a different situation. Like the snowflake defines like a two-dimensional plane that it lives on mostly, right? I mean, it's a three-dimensional thing, but just barely. So I would say in that sense, the liquid water is more symmetric, meaning that like there's more different rotations and reflections and translations that I can do where I end up in a state which is not distinguishable from the original state. So my answer would be liquid water.
Yeah.
But like I said, I think it's debatable. I mean, certainly in the everyday meaning of the word symmetry, like are there two things that look like a mirror image of one another? The snowflake is more like that in the sense that it might have like bilateral symmetry, like 60-degree rotational symmetry. But I think this is interesting for what it reveals about the way maybe physicists specifically talk about symmetry, or maybe just me. And actually, this concept is very powerful and important in physics. There's a famous result, Noether's theorem. So Emmy Noether was one of the, first of all, one of the early women to make a really big contribution to like fundamental physics relatively early in its development. But her idea was that a symmetry and a conservation law are two different ways of saying the same thing. So the idea is that like, why is momentum conserved? And it's because space has a translational symmetry. Like if you say that the laws of physics are the same here as they are over here, then actually that means that momentum has to be conserved. Those two statements are fundamentally related in a very deep way. The same thing with like rotational motion, like conservation of angular momentum. Like if the laws of physics are the same in this orientation as they are in this orientation, which we think that they should be, then that implies that rotational angular momentum has to be conserved. And of course, all these kinds of things like balancing your bicycle or the orbits of the...
all that build up to the failure.
Oh, boy. All right.
Neutrino, thank you for stopping by. It was a pleasure. You had asked a bunch of awesome questions and kept us moving forward. We really appreciate it. Singus, I hope you got that answer right. If I get it wrong, I quit living. Oh, nope, that's the end. RIP. See you later. Well, thank you for the follow. Good luck. Anyway, Texas Space Agency. Oh yeah, Texas has a cold front coming through, and you may or may not have power sometime soon. So yeah, gather that firewood and enjoy the blizzard 2020. Is it actually going to snow? I didn't look. I know it's going to be cold.
I have a grade school friend who lives in Texas that says they've been hoarding water ever since October in case of this. Apparently, like in Florida here, all the water sells out when there's a hurricane coming.
Yeah.
Apparently, ice storm is the Texas equivalent of this phenomenon.
Brutal. Don't put that curse on me.
It's because people's like houses aren't built to handle the cold. I mean, no one ever loses their water. I grew up in Wisconsin. No one loses their water because it's cold outside. Like, it's absurd.
Yeah. No, I'm from Minnesota, so I get it. Well, they were just built for it, but Texas not so much. I've got 3 inches on the ground and it's not stopping. Brutal. I mean, snow is fun until you get enough of it or you don't have the infrastructure to deal with it. Sewer line. Yeah, even in Florida, we did 26 degrees recently, which is kind of crazy. Which isn't terrible unless you own an orange
some of my
crop.
peppers are still alive and kicking.
Did you wrap them or anything? Or you just let them go?
The really spicy ones died, but the like I grow like the Calabrian chilies, like the red pepper flakes you get at like an Italian restaurant. Those are doing fine. It is in the mind.
So I just looked at it. Maximus Minimus won this again with a 47-1 payout. I'm fairly convinced Maximus is betting against the community at large. Just saying, I'll put 10 points down. What's the worst that happens?
Maybe Maximus is a plant.
Yeah, no, they're using game theory here. They're not even trying to answer, which is okay. We're here about meta-analysis as well. The chickens all got frostbite last year. That's something. All right, we're at 10:08. Do you want to switch to Mass Effect? Or do you want to keep
play a little
hammering
Mass
through
Effect. That should be relaxing.
Yeah, we'll close with the highest resolution game of the night.
Spoiler warning, I'm about halfway through Mass Effect 2. I just cleared the collectorship for those of you in the know. And now I'm knocking out loyalty missions for my squad mates. I'm playing as an adept, which is like the mage class or whatever of Mass Effect. You like throw purple space magic at people. And I have the loyalty missions for the two main like squad mates that I'm using available to me conveniently in the same location. So that's probably where we can go. This game looks amazing and runs like a dream on the PS5. It's pretty much locked 60 frames per second, runs at full 4K, have a nice big television at home. Looks great.
But you guys are watching it in 480p. No, I'm just kidding. I think we do 1080.
But even if you render at a high resolution and like downsample to a lower one, it still looks better than rendering natively at like 480 or whatever.
Yeah. So we just switched to Metronet fiber optic internet.
Oh yeah,
so
how
our
is
uploads, it's awesome. It's 900 up, 900 down.
Comcast before?
Yep.
Is it any cheaper?
Yes, it is. So we went from 120 down to 70. So we don't have TV or anything, but we didn't use it anyway. So yes, it's worth it. This stream brought to you by Metronet. Just kidding. They're not sponsoring anything. I just really like their service.
If memory serves, there's a nice little physics lecture by the like gunnery sergeant here when you get off the ship at the Citadel. I think that's playing.
This amazing Texas Space Agency was talking about 3 inches of snow. My 3-year-old daughter keeps running in and singing, "Do you want to build a snowman?" That's the worst part. Let her live the dream of Frozen. So how old's your oldest kid?
3.
3? Okay. So almost to the point of having favorite movies and strong opinions about...
His favorite movie is Cars.
Cars, okay.
I don't know, it's okay, I guess.
Yeah.
Not what I would have picked. We really wanted to try to get him into WALL-E because I think it like works as a legit like sci-fi movie and also is like interesting for adults, but he just finds it boring, right? There's like a half hour at the beginning with no dialogue. Out. He's not there for that.
So have the musicals hit yet? The Frozens. I've seen Encanto like 80 times in the last 3 weeks.
For musical content, my son pretty much only wants to listen to AC/DC or other like similar like early to late 70s like kind of like hard rock type bands. This all seems fine.
My 3-year-old's favorite movie is Rambo First Blood. I mean, you can make fun of any of the Rambos, but not Rambo First Blood. That is an excellent movie.
That's like an amazing...
It's about PTSD and
it's like an amazing
psychological
movie. It's
analysis.
not all what you would expect if you grew up during the... Because I never saw it when I was a kid. I remember like the Sega Master System game like for Rambo 2, which was just you're like mowing down these like Vietnamese guys, like hundreds of them.
Yep.
But the original Rambo is actually a very interesting movie. It has lots of interesting stuff to say about like... There's lots of interesting stuff to say about like the relationship between like the military and society and like police and society, and it feels much more modern than I would have thought.
No, that's a good point. It aged very well.
Remake it with him as being like an Afghanistan survivor or whatever, right? And it would work just perfectly well as like a normal modern movie. Sir Isaac Newton is the deadliest son of a bitch in space. What is Newton's first law?
That is the perfect opening for Ask a Scientist Gaming and Mass Effect gameplay. Excellent choice. Really tapped into physics tonight with between VVVVV and this. Uh, anyway, anyone just joining us, Ask a Scientist Gaming, mediocre gameplay, expert level science. We have...
We've seen some truly mediocre gameplay tonight. I got lost in the first real dungeon.
Some excellent
of A
gameplay.
Link to the Past. I got like 3 items in Metroid, I guess, before I started going in circles. Not too bad, considering I haven't played it in like 30 years.
Yeah.
But VVVVV, I was doing okay. It would have taken me a long time to clear that like escort mission stage.
Yeah. I mean, it's fun. It introduces new mechanics every level. I really like that. Speaking of which, so 2 weeks ago, we didn't have a guest because of COVID spike, but my wife and I played It Takes Two. Have you seen this game?
I saw you playing it. I tuned in during the stream because I get the email notifications now.
You and Rachel should play that game if she's up for gaming, if she's okay with analog controller, because it's a lot of fun. It's collaborative problem solving, very similar to what VVV does, where it introduces new mechanics every level.
It looks cool.
It's really fun. My wife is not a gamer by any means, but she likes it. I don't know if you played Portal at all, but it's similar to that, except it has new mechanics, so I'd recommend it. All right, Texas Space Agency. My favorite part about the snow day, I've been quoting Bill Murray's Groundhog's Day 1994. What blizzard? It's just a few flakes. Groundhog's Day is a classic.
It was Groundhog Day today, right?
Was it really? I do not keep track.
Yeah, right.
Of
February 2nd. Isn't that today?
No, that makes sense. 2/2/22.
That's true. When are we going to have our next completely mono-digit date? Not for 111 years or something, right?
Well, on the 22nd, we get 2/2/22.
Oh yeah.
If you want to count that. Yep. The stars aligned. Oh, that's a good point. We won't get it till 3/3/3/3/3. How's the volume? Can you guys hear this game? I haven't actually turned it up at all.
Where can we find him?
If I knew that,
Yeah, don't worry. I'll talk my way through security here and get to like shooting people in a warehouse.
Reese's Pieces brings up an important point. 2/2/2022 is on a Tuesday. Symmetry. Model that with group theory.
Yeah.
Groundhog's Day. I'm sure that has something to do with particle physics and multiverses, but they didn't really dive into that by any means.
Yeah, so one of the things I did at work today was I was telling you about like doing project management, and we have I don't even know what to call it, dress rehearsal, pre-review for a Department of Energy review that our project is going to have in April. So it's like a friendly team of reviewers that are trying to help you strengthen the case for your review. And today we did what they call drill downs. So you take a piece of documentation that you wrote to justify the cost of some like component of the detector, and then like accountants like go over it with a fine-tooth comb and try to find inconsistencies of like in paragraph 3 like subsection C or whatever, you said that there were 112 crates of shipping, manifest that you have to pay for, and then down here you say it's 117 or whatever. And we've done this exercise now with the project for several different layers of review. In the Department of Energy construction project, you have these reviews basically once a year or something for the duration of the project. They all have different names, but similar ideas. So it felt really like cosmically appropriate that on Groundhog Day I was like defending this same stupid documentation that I wrote like a long time ago.
Yeah.
For the umpteenth time, and like the numbers all still like multiply out to be what it says at the top.
Yeah. With that said, I really appreciate that there are people that are really excited to do that job. Just to like find the loophole, and like you need people like that. Like,
I mean, it's your money, right?
Yeah.
Assuming you guys are all in the U.S., like it's your money that we're playing with, so like you should be happy that people are checking to make sure that we're not wasting it.
Yeah. I've never played Mass Effect. I've watched some of the gameplay, but I've never played it.
That's quite an admission.
Is it? So I went with Xbox. I don't know if Mass Effect is cross. I think it's just PlayStation, isn't it?
Mm-mm. The first Mass Effect, I think, was an Xbox exclusive, actually.
I did not know that.
Because when you first bought Mass Effect 2 for the PlayStation, you had to there was like an interactive comic at the beginning to like catch you, because there's all these decisions you make in the game that then impact the plot of the second game.
Yeah.
But you didn't have a save file for the first game because you were on, it was PS3 at that time. So you can still do that if you just want to skip to Mass Effect 2. I mean, the first Mass Effect is kind of janky in some ways, but it takes the sort of science fictional premise the most seriously. Mass Effect 2 is more this kind of Dirty Dozen type scenario where you're recruiting all these like malcontents or whatever from across the galaxy and then convincing them to be on your team. It's more about social.
All right, we have 2 predictions left. We'll do one of them sometime soon, but Maximinimus has an interesting question. Note that this will be on YouTube at some point. So what particle physics project would you consider a waste of money? Someone in your community might hear your answer to this, so you don't have to answer if you don't want to.
I'm going to answer what I think is generally regarded as a very expensive project, which has been I don't think it has, at least not yet, hasn't really come up with anything to justify the expense.
Oh, that's interesting. Framing this in the return on investment type.
Yeah, well, I think that's the right way to do it, right? I mean, if it was just such a ridiculous idea that it should have like never been funded, it would be very unlikely for something that like a true boondoggle to like make it through all the layers. Or like, there's a lot of smart people like looking at these projects and figuring out what they can do. So on the space station, on the International Space Station, there's an experiment called AMS, stands for Alpha Magnetic Spectrometer, and it's basically like if you took a general purpose detector like CMS and put it on the space station, and there's no particle accelerator there, but you are like above the atmosphere, so you get a better crack at detecting all these like cosmic rays that are coming down. And there are some unknown questions in that area. The energy, the sort of flux of different types of particles can tell you something about what must be happening in like distant galaxies or whatever to produce them. So it's not a crazy idea. It's not a crazy idea to have this, but you know how expensive it is to launch things into orbit, right? So if you had just took the same detector and built it on the surface of the Earth, it would be so much cheaper because you had to pay like to bring this thing up like piece by piece. So it's very expensive.
I mean, is the idea that the atmosphere is going to block things that it'll see up there? Is it justifiable? Is that?
It's true. I mean, if you want to, so what their main like flagship measurement is to measure the flux of positrons, which tells you something about these high energy. We talked at the beginning of the stream about electron-positron annihilation being one of the most basic like interactions that can happen in particle physics. And so it's a good probe of like what's happening at like higher energies out there. It's just, it's a very, very, very expensive experiment compared to the amount of like results that it can deliver. So I'm not going to say it's completely unjustified or even that it's a bad idea, but just the nature of it being in space makes it very expensive, and it's a high bar to clear for being a good use of the resources, because it's a little bit of a zero-sum game, right? I mean, whenever you're doing an experiment, it means there's some other experiment that you're not doing. So that's one. That would probably be my answer.
Yeah, I think that's a very fair answer. And honestly, the scientists behind that would probably agree with you, right? I mean, they want to see the result. They're not going to...
now I am going to take the fifth.
All right. So we've asked many questions. I had a few in particular that I want to ask. I'm going to throw those out there right now. What is the Earth is flat / anti-vax equivalent in your field?
So I triggered on this question for two reasons. One is I think like the concept of anti-vax has seen a very rapid evolution in the last few years. So framing the question that way just made me think of Like, it used to be that an anti-vaxxer was like a liberal, like mom from California that didn't want her kids to get the measles vaccine.
The granola mom, yeah.
Yeah, and now it's like the cultural assumptions behind that term and like who it's referring to have almost completely reversed, which I just think is interesting.
Yeah.
Because, I mean, there's nothing more American than like being hateful and suspicious towards like big pharma, right? That's something that like politicians have exploited for decades to get people behind various like reform proposals or whatever.
Which is not completely unfounded, but
exactly
to the extreme. Yeah.
The details matter. The technical details matter. Exactly which vaccine are you talking about and for which reason are you suspicious? Like, it could be that for some vaccines for COVID or whatever, for some populations, like, it's totally possible that the risks could outweigh the benefits, right? That's not a crazy thing to think. It's just the details matter. Like, what are the actual rates of different side effects or whatever? And it's almost never the level on which we're having the discussion. There's just an assumption people are stupid because they don't agree with some highly educated opinion that I have. And anyways, to climb off the soapbox and actually answer the question.
Soapboxes are fine. We're drunk in gaming. Soapboxes are okay.
In particle physics, there has been a tradition now for, 30 years or something to always say that the next experiment that we were going to do would reveal the particle nature of dark matter. This is something which is always held out for every experiment, that it's going to give some insight on this question. And so far, every experiment that has done it has failed to show any positive results. We still have very little idea of what, if assuming dark matter is a particle, I mean, all the matter we know is made of particles, so it's a reasonable thing to assume. We almost know less now than we did 30 years ago about what it's likely to be, because we've done so many experiments that have come up with negative search results.
Yeah, you've ruled out things.
I just saved this girl from being shot by these... It's like a Lord of the Flies type situation. This ship crashed, and the people have like turned on each other. So it used to be a very like fringy idea that actually maybe the answer isn't that there's dark matter, but that the law of gravity is just subtly different at very long length scales than it is at like lab scales where we can measure it more precisely. It would be very hard to do any experiment on Earth that could ever tell you if gravity was just subtly a little different at like long distance scales than the like Newton's laws. Whoa, this guy on fire just floated right through me. I love this game. The combat is like so, it's kind of ponderous and balletic, but then there are these like wild powers and you're like sucking guys into the air. They made a Star Wars game before this, and I think they probably owe George Lucas some royalty for like not changing the concept that much for their own quote-unquote IP, but... So anyways, the idea that dark matter might actually not be a particle, but might be some subtle tweak to the law of gravity, I think is something that would have been regarded as a crank opinion, like, in the past, but is becoming, at least to me, like, more interesting and defensible.
That is intriguing. So I've had astrophysicist David Collins on. Next time he's on, I'm gonna pick his brain on that one. Because that is a fundamental assumption of a lot of their rules, right? That gravity is a constant. And it just...
From what I understand of David Collins, he's a lot about applying electricity and magnetism to, like, large distance scales. So there might be equivalent problems there.
Yeah.
How do you know that it's... The thing is, electromagnetism, because it's so much stronger of a force, it's much easier to measure even tiny deviations in a laboratory experiment. So we have... No kidding, like, verified the basic laws of, like, so QED, the quantum theory of electricity and magnetism, has literally been verified out to, like, 25 decimal places of calculation at this point. So the hiding room for new phenomena is just a lot lower than it is for gravity. Just, we don't know that much about gravity because it's so weak. It's just really hard to do experiments.
Mm-hmm.
So that's my answer for fringy opinion that might become mainstream in the future, depending on how things evolve.
I mean, that's really fun. I hadn't heard that before, but I don't keep up on astrophysics. But, I mean, dark matter is just a fudge factor in the math that they can't get to converge. Maybe the foundational principles is wrong.
I mean, I think you should take it more seriously than that. I think that's a little bit of a glib summary in the sense that there are these things like this famous bullet cluster, right, where there's suggestions that you can actually use the differential motion of like matter and dark matter in like a visible galaxy to make pictures of how the distributions don't exactly track one another. And there are debates that occur about how strong that like indirect evidence really is, but it's very much still, I would say the favored explanation is that there's dark matter out there, and people are getting more and more creative about the types of experiments they can use in order to look for dark matter. But
yeah, I think when David was asked what the like next major breakthrough would be, something related to dark matter explaining that phenomenon. So
yeah, it's one of the most biggest and most important unsolved questions in physics.
All right, so we're crossing the 10:30 mark. Anyone that's just joining us, Ask a Scientist Gaming, mediocre gameplay, expert level science. Dr. Ted Kolberg is happy to talk about particle physics, high energy, smashing particles into each other. This is a real question. What is Dr. Kolberg's favorite Disney song, and how much can he sing before a copyright strike?
This is a real thing, right? Like, didn't they... was it Disney or something? I just read there was some like astronomical number of like YouTube videos that just got taken down for copyright claims or whatever.
Yep.
The whole thing is so strange to me because like it's painfully obvious that like Disney songs are part of our common shared like cultural heritage. The idea that if you accidentally lapse into one while you're doing something else, that now you've committed some kind of like theft that needs to be addressed like by force of legal action, I just find absurd.
I mean, they have a small army pursuing that, which is pretty crazy.
I mean, they have no choice, right? Because they have like investors that rely on their like income from Disney stock or whatever. Like, so they have to do their like due diligence and follow the law. I think copyright law is just something where like the original purpose has been so lost behind the maximization of a very narrow idea of what's like good for companies or whatever, that like, I mean, the idea that books stay under copyright now for like 100 years or whatever, it's like,
it's crazy.
You know, the reason that a lot of old books are still famous to us, The Wizard of Oz and Alice in Wonderland and stuff, is that there was no copyright back then, so there was a thriving ecosystem of like rip-offs and like what we would call like fan fiction now, but that was like sold for profit, right? And that helped to cement the position of those things as like major cultural events.
Well, you see that now too. Like you remember the Napster controversy and Metallica and the battle against that, but it's been shown experimentally that like the songs that are downloaded illegally sell better, and it's because it's propagating through the culture, and enough people have it, it has a critical mass, and more people buy it. And so the modern equivalent does exist, but it is combated at every turn right now.
I mean, the idea that like, well, we could go way off on a tangent about like how the economics of the music industry are changing or whatever, but like I feel like there should be someone in the area of copyright law that like speaks for the, you know, it's not like somebody repeating a Disney song on their stream is like taking income out of the pocket of like the songwriter, right? Like that true. Otherwise we would be, I guess, streaming it from Spotify and paying them 1/100th of a cent or something. Like the whole thing just seems ridiculous to me. There should be a much stronger presumption in favor of like creative people being able to make new stuff.
Yeah, and the rules are weird. Like on Twitch, so we've had 3 of our YouTube videos copyright claimed, which means I haven't monetized any of them, so it doesn't matter. We just keep them up. No one makes money off of them. But it was basically like the starting audio behind NBA, or what was it, NFL 2K something or other game. Another one was Rock Band, which apparently you can stream live because it's a performance, but when it's on YouTube, it gets a copyright claim. And so I don't know how these rules work. The other one is the game was I think it was the Necro Dancer. I don't know if you've seen
the Necro Dancer. Yeah. In fact,
that.
I might have picked that game. Oh no, I might have picked that game to play if I hadn't seen that somebody else on the stream had already done it. Because it's like an appealing like retro style game, but with more like modern.
Matt Hauer played that. Yep. So that had a copyright claim on it. So it's been interesting to see this from that end, but apparently on stream it's okay. You don't get taken down typically live, but on YouTube it definitely comes back to bite you.
Interesting.
All right, 10:32. We should probably do another prediction. We have 2 of these left.
All right, let's do the second one.
All right. So, anyone that's not following, click the follow button. We're about to do a prediction, and prediction on our channel is science questions. So you will get a science question that pops up. You can use your standard internet units to answer this question. Ask a Scientist Gaming honor policy. Answer it to the best of your ability without using Google to search for an answer. All right. So the prediction is up right now. It says a 1940s particle physics lab were 1940s particle physics labs were under a mountain or on top of a mountain. This is an intriguing question. Where do you want to measure stuff? Do you want to do it underneath a mountain or on top of a mountain? Answer your question now. This is particularly related to 1940s particle physics. Where are they building their laboratories to measure particle physics?
And if you're one of my students, I would say more important than the answer you pick is like, why? What's your reasoning?
We cannot include explain your answer, but is it under a mountain or on top
That's
of a
why I said if.
That's fair. Oh man, test analysis is actually one of my hobbies. So I published a paper recently using these statistical models to describe tests and how to like pick if a question is good or not.
You mean like a chemistry test?
Yeah. So general chemistry is the class I teach with like 300 and something students. So I use it's classical testing
What lecture
theory.
hall do you teach in? Sorry,
The HCB building, the huge.
Yeah, I've had exams in those rooms before.
They're huge, aren't they?
Yeah.
I like those rooms actually, but yeah. Testing and assessment is one of my hobbies on the side.
And just one more inside baseball thing. Do you bring demos like with you from somewhere?
No,
You have a demo cabinet?
So I don't do demos. I actually looked into this, and it turns out most of the research says demos don't help with learning or long-term retention of knowledge in any way.
It's a shame. It would be nice if it did.
I mean, so what's
you don't feel like duty bound to illustrate that things are actually real, that you're not just making it up.
So what's lost in those type of studies is like, does it increase the number of chemistry or physics majors? Does it increase enthusiasm? Like, there's no data to support any of that. And so I kind of did a cost benefit and like, is it worth the time? Is it worth the effort? And I just...
Well, also, if you don't have a setup nearby to manufacture them, then it kind of answers it for you, right?
Yeah, so HCB kind of rules out most of our chemistry ones, but yeah.
All right, so what do people think about the mountain question?
All right, so the answer is everyone guessed under a mountain. So what is the correct answer?
Everyone is wrong.
Oh my God,
today,
nobody bet against it. 1940s.
Somebody left free money on the table. At a certain margin, you should just bet against the conventional
Maximus,
wisdom.
where are you on that one?
So actually, we talked earlier about how this like neutrino lab that made this claim about, it wasn't the lab that made the claim, but some specific scientist, but where this superluminal neutrinos thing came up, that was under a mountain. And that's actually, in the modern research world of particle physics, you'd be much more likely to find it under a mountain. I'm playing on hardcore, by the way, so like I probably shouldn't be dying at all on this mission, but if you play Mass Effect, I mean, there's insanity, which his character's not really powerful enough for that, but during the 40s, actually you would have put it on top of the mountain. And so in modern experiments, we are the source of the particles, the neutrinos or whatever. And so you actually want to limit the interference from cosmic rays in your experiment. But of course, in the 1940s, they had no accelerators, or they were just in their infancy, right? The first particle accelerators were just a few inches in diameter and very just KeVs of energy, not anything that you would need giant detectors for or whatever. And so actually your best source of particles to feed your experiment actually was the cosmic rays. And so you want to get as far up in the atmosphere as you can. Now, you could use hot air balloons. You can put an experiment on a balloon and send it up higher than a mountain, but that has all kinds of other problems, right? It limits the weight, and sometimes the balloon falls somewhere in like enemy territory or something that makes it hard to recover. So if you want like a lab where you can do controlled experiments in the lab and not have to fart around with balloons, you would put it on top of a mountain. So there was this generation of particle physics labs which were basically at like ski hills. You would like ride the lift up to your alpine retreat or whatever, and have your lab where you were exposing photographic plates to look for new particles in cosmic rays or whatever. And that era in physics lasted, maybe 10 or 20 years before the ability of the accelerators to produce particles outstrip the ability of the cosmic rays to do it. So now we would much prefer an accelerator. The rate is much higher, and you control the conditions, right? You can choose the energy to benefit the specific experiment you want to do. But for those early discoveries, the best thing they could do was just wait for a cosmic ray to go through and hope that it contained a new particle and that you were able to reconstruct it. And so that's what they did. They put things up high and just waited. And people actually still do this. I have a colleague from when I worked at CERN who used to work on one of the big collider experiments and actually started working instead on the modern day version of these balloon experiments. So they still do them. There are still some searches. It's a fairly cheap thing to do compared to building a collider. So if you have a specific question you can answer that way, it might still be worth it. So the technique is not totally lost, but in general, the labs used to be at high altitude, and now you put them under as much Earth as possible to limit interference from cosmic rays.
No one bet against the trend. I'm a little disappointed. I'd like to see when people are skeptical.
Maximinius is going to have to give back their honorary doctorate in particle physics.
I like it. Oh, that's fun. Discussion in chat regarding GIS. That's pretty fun. All right, so we're at 10:40. How long do you need to beat NARC?
I got to admit, I came in with big plans, and once the scope of the task became clear to me, I folded like a cheap suit or whatever the expression is. So I'm pretty sure I can get through to the car level on the bridge pretty okay. I might only have one life left by that point because I haven't fully mastered the art of jumping over the bullets, which I see is how you gotta do it. But I haven't quite worked out the timing of that. And then from the first time that you jump in the car, everything from there. So I haven't even attempted Mr. Big, for example, unfortunately. So This might be the time for Game Genie. I don't know.
We'll say 10 minutes. I'll have Game Genie on. You have nothing to prove here. Full disclosure, Ted knew we were playing NARC because he's seen the stream before. So
somebody's NARC'd on you.
Yes, no, it's a mainstay of Ask a Scientist gaming at this point.
We're gonna earn back the social credit from our earlier unfettered discussion of research chemicals.
All right, so you ready?
I'm ready. Let's not start this lengthy dialogue scene.
All right, I'll switch over. Switch over to our NES.
Oh, I gotta pick up the Mangler again.
Oh yeah, no, it's the rectangular controller, the crippler, the arthritis inducer. It is time, ladies and gentlemen. The thing I'm missing right now is actually a timer. So let me pop that guy up. So you notice we have the foot pedal. We take this very seriously. No, for speed running.
Oh, because that's how you trigger the start of
clock,
the run.
Yep. So you don't have to take your controller off. All right, so
clever. I would have assumed it would keyed to a specific frame in the game or something.
Some of them do, but NARC is not popular enough to merit that attention. So you are on your own, ladies and gentlemen. If you haven't seen this game before, we're about to win the war on drugs with NARC. So Ted, please
I feel like this
free.
splash screen implies a 2-player mode, but that's not real, right?
No, there is a 2-player mode.
There is.
If you get good at this, we could have the 2-player world record.
All right. Okay. All right.
So that record
That's something to shoot for.
It's 9 minutes and 54
Now that I got tenure, what else do I have to say, right?
Exactly. All right, ladies and gentlemen, it is time for NARC. Go ahead and start whenever you're ready. The clock doesn't start till you actually gain control of the character.
This is a shady-looking character. Das Wolfgang.
Yes. The flasher. All right. But you're right, jumping over the bullets, turns out every 6 shots costs you a second.
Crouching into the bullets, on the other hand, is not a valid speedrunning strategy. Yeah, I see that. There's 2 frames of... All right.
And each death costs you 1.75 seconds.
Those are that's the precision born of long study and practice.
So this goes beyond just casual gameplay. I got challenged by chat to speedrun this game because we started playing it regularly, and I committed.
Oh, did you see that? I just killed that dog on the first try. Nice. I hate those dogs.
But yeah, I am the current world record holder in NARC. Of the 11 people that have posted speedruns, I am the fastest in the world.
Congratulations.
So yeah, that's on my resume for full professor. It's got to count for something, right? But yeah,
it's clear evidence they're paying you too much.
Well, so what's fun is that I use scientific method to figure out this game, right? Because it's a lot of trial and error, and what physics rule this universe that don't rule ours? What patterns can you find? And I have a particular thing on Mr. Big that I did that saved about 15 seconds per shot.
So you like originated some new tech on Mr.
Yes.
Big?
Yep, and it's on the description of my world record speed run.
Okay.
But going beyond that, my brother is a...
Is there a video of like you while you're doing the run?
No, it's just the run. I haven't recorded.
Okay, so the one that I watched must have been somebody else because it definitely wasn't you.
Yeah, well, so I wasn't on the video, the top ranked one. I just record the video rather than me on it. But... yeah, going beyond that, my brother, who's a moderator for this stream, actually he's reverse engineering the game.
Older brother or younger brother?
Older brother. So electrical computer engineer, actually figuring out how this game works. And so that's where I know the jump is like 3 frames is how much time you have to tap that button. And this blue card is a like 1 in 7 chance.
I just have to kill until I get it, right? Yep. That's how real police work is done.
You know, this game is fairly realistic in some endeavors. But
I love, like, I know there's like an Uncharted. I guess you're not a PlayStation guy, so you probably never played the Uncharted games. It's
I'm
kind of like Indiana Jones ripoff, except Indiana Jones maybe kills like 24 Nazis or something in a movie, but like Nathan Drake kills like 150 people during the Uncharted game. You have to think at some point, like no matter what like third world country they're in or whatever, that like someone is going to catch on that like history's greatest like mass murderer is operating, right?
Yeah. This game is why I don't do drugs. Well, something positive came out of it.
So this is the same Rare that went on to make like Donkey Kong Country and GoldenEye and Perfect Dark and all those games.
Well, I mean, so you have to forgive these guys because they were taking an arcade game, a dedicated arcade game, and trying to port it on into an 8-bit Nintendo.
And it was also made with like government funding, right? So I'm sure that didn't help the case. Right?
Is that true? I don't actually know that.
It has like the DEA like seal in the game, right?
Yeah, they say contact your DEA agent. You got an early car spawn, actually.
I gotta jump in. There we go. What? Yeah.
Oh!
You could tell I knew what I had to do, right? I didn't do it. I'm just gonna soldier on here.
Yeah. Well,
that's so punitive, though, because like until you've done it enough, I ran it like 20 times before coming over here. That part just to see. At least I can like gracefully. Is this like a traitorous cop? Is that what this guy is supposed to be?
It's Joe Rocca. I don't know what his backstory is, but yeah, he likes to punch you in the face and can take quite a few bullets. But yeah, the first 3 bombs there are set every time, but the bombs after that are RNG, and it's depending on your position on the screen.
Now I should get another car here sometime, right? Or
after the helicopter.
In a while.
Yep. So if you get your time under 10 minutes, you are like a top 5 player in this game. In the world.
The world is a very large place.
The DE agents don't need sleeves.
Have you looked into applying this? Is there an office in Tallahassee you could like present your speed run as evidence that you should be on the force? I'm taking you up on this like 40-year-old offer.
Well, I mean, it's worth a try.
This is real pulse-pounding gameplay right here.
93%. Are we talking physics? This isn't Mass Effect. No, you're right. I didn't change the game. I apologize. 93%. If you have physics questions, ask it, because Ted Kolberg is here. He's an expert in high-energy particle physics, the Large Hadron Collider, and all the detectors involved. But now we're playing NARC on the Nintendo, because that's what we do on Ask a Scientist Gaming. Mediocre gameplay with expert-level science.
A man must have a code.
So if you have questions, 93%, throw them in chat right now. And I will change this to NARC. And I apologize if you're here for Mass Effect gameplay, because that is not what we're doing now.
Oh my god.
I'll change it to...
I apologize to everyone who's watching. That was the shortest car ever.
You'll get one more here.
I can only imagine what happens if we drive the car into one of these barrels.
Nothing, actually. The barrels pop up in the air and they don't do anything.
Really?
Yeah, no, that's weird.
I would assume whenever I see a barrel in a video game that it's full of like the most explosive substance known to man.
Ooh, that's 93% is a fluid mechanics PhD. So different physics, but complicated enough.
Wow.
So that
Fluid
counts as condensed
PhD.
matter, presumably. I mean, physics is weird that way, and I talked to both. I've had Han Wei Gao on and David Collins. So you have condensed matter, astrophysics, and high energy particle physics, and you're all grouped in the same department, despite being very different things.
Yeah, and it depends on like different departments will also have other like subspecialties. I did my PhD at Notre Dame, and we had a big group doing what they called complex systems, which was using like different approaches of like machine learning and also like theoretical condensed matter approaches largely. I think a lot of people had background in condensed matter, but they would address just various and sundry problems like what's the most efficient way to board an airplane. Turns out the answer is randomly, but nobody would stand for it.
That's awesome.
In fact, they did a lot of work I remember on disease transmission dynamics. I wonder
So if you stay on the bottom, you should be fine the rest of the way.
all right, I'm just going to put the pedal to the metal.
Yeah, now we're going to put an
Another good
asterisk.
policing practice, right?
Now we're going to put an asterisk on your time. Unfortunately, no, I'm just kidding. I always wanted to ask a particle physicist how particle physics affects my boundary layer problem. Can you further elaborate on what the boundary layer problem is in fluid dynamics or fluid mechanics?
That clown character is terrifying.
Yes. I mean, it's a clown with a
A
knife.
knife murderer.
And
There's many of them.
Note the blood that's being generated on a Nintendo.
Yeah, I thought that was verboten.
Yeah, well, so they changed to like crack in some of the logos to quack.
I noticed that.
But the clown stabbing you and death or blood being
They want
generated
to say
is acceptable.
quack, but an adult bookstore is fine.
They did remove the hookers from the arcade game. So
I thought these were not the clowns are different than the hookers.
Yep. No, the hookers were independent. You couldn't kill them
Oh
in
my
the
God,
arcade
he's
game. So you're going in that door.
frantic. Oh, the silver safe card is a ruse.
Yep. Well, it's inside of that door.
Oh, I see.
Yep. All right, we have one more prediction. Should we pop that up now? It's 10:50. We got about 10 minutes left. I think it's time.
Yeah.
All right, so if you're not following us, click the follow button, get your 300 standard internet units. Rather than betting on games here, we bet on scientific predictions. And so I've had a mixed batch of questions tonight in terms of the success or the response. Everything from 0 payout to 143 to 1. We're going to throw out our final prediction of the night. The question is, the proton lifetime is at least 10 to the 10th years or 10 to the 36th years. So how long is a proton lifetime according to at least current models that describe them?
This isn't a question about models. This is a question about experimental measurements.
So experimentally, how long do we know it is? 10 to the 10th or 10 to the 36th? Or greater than 10 to the 10th or 10 to the 36th? Throw your predictions in there now. You're going to, on the Ask a Scientist Gaming Honor Codes.
So these guys are like pimps throwing like Molotov cocktails.
I think they're sticks of dynamite, but I don't actually remember. So we can actually play the arcade version of it. It was re-released on the GameCube under like classic arcade game.
Stretching the definition of classic.
Yeah. Well, I mean, the arcade one was beloved. Like people really liked the arcade game. This one, not so much.
Yeah, I was starting to say before we started the stream that I remember the arcade cabinet for this game because we used to have birthday parties at this place called Butler Skateland, and like right next to the WWE WrestleMania machine that had a big the $1 Million Man was like the theme of the WWF cabinet, and right next to that was the NARC thing, and that's where I remember the DEA like logo would appear like between the like gameplay loop that would play.
Well, there it is. Nice.
Green safeguard in the like marijuana warehouse, the greenhouse. Yeah.
Fun factoid: in the original arcade game, it did not have that level. That was actually an updated patch that people downloaded to the arcade. So apparently, they felt that level needed to exist, and they actually downloaded
perhaps
and updated
a change in like a DEA PR strategy or something like inspired this change.
Interestingly, it's the only level that goes left, so take that for what it's worth.
That's true.
Yeah.
It's such a common thing nowadays to move left in video games that it doesn't really register to the modern.
Yeah. No, did you play Mario 3? I guess you didn't have an original Nintendo, but Mario 3 only had one level that went the other way, and it was just mind-bending for everyone.
I mean, I had like Super Mario All-Stars on this, so I got to Mario 3 like years later.
Yep.
I definitely went over to kids' like houses for sleepovers or whatever and played Mario 3 on the original Nintendo. We just never had one.
All right, so proton lifetime, at least 10 to the 10th or 10 to the 36th? What is your answer, Ted?
So, the answer is 10 to the 36. And it's actually an interesting question. How can we possibly know? So the universe is only about 10 to the 10th years old. So how can we possibly know that the proton lives 26 orders of magnitude longer than the universe, right? You would think that it would be really hard to make any statement about what would happen on timescales much longer than the length of the universe. But the reason why I thought this was an interesting question was that it reveals something about the power of having like large numbers, right? So you can extend your reach in terms of like physics, not just by, you know, observing one particle
So you have these cards already.
Oh, these are the red safe cards from the first
from
level?
Earlier, yep.
Oh, it's kind of like a summation of everything we've accomplished up until now.
And so if you do 2 players, it matters who picked up that card.
That's really user-unfriendly.
Yeah. So you have to remember who won it or who got it first.
So even though, like, the universe has only been around for 10 to the 10th years, and humans have only been around for, like, 10 to the 5th years or something, right, of that time, we actually know that the lifetime of the proton is at least 10 to the 36. And the way that we get there is by not waiting for really long times, but assembling huge numbers of protons, right? So even if the lifetime was much longer than the lifetime of the universe, a mole of gas, right? That's 10 to the 23 atoms. Each atom has like multiple protons in it, right? So if you had like water, which is what they use in these experiments, you have a big tank of water because there's two hydrogen atoms in each water that the proton could potentially decay. And so by assembling, you know, many, many moles of water in the same place and then just watching for a proton to decay, you can, even though you're only sampling a small part of the lifetime, the large number of protons lets you make actually a really strong statement about how long they must live. So this is something that many grand unified theories busted.
Yeah,
it's like for the score bonus, I guess?
Yeah, if you stand on them, you can bust them instead of shooting them.
But it's slower than shooting them.
Oh, yeah, no, it's not good for the speed run. But
if you're going for a high score?
Yeah, presumably. Or you want to be the noble cop that doesn't kill everyone instead.
Well, this guy named his company after the drug that's ravaging the city. That seems like questionable decision making. Oh my god, it's a murderous wheelchair dude.
In name brand recognition, he has won that game.
That's foreshadowing, right? Isn't Mr. Big also in a wheelchair?
So that's Mr. Big.
That's him?
Yep, and so you have to shoot him with a rocket. That's
a rocket.
That's phase 1 of him.
Which means tap A?
Yep, tap A.
All right, well, where did he go? Oh, there he is.
He's a slippery guy.
He's fast.
Yeah. So my major contribution to the speedrun of this game is that you'll see when you rocket him. I'll show you when it happens, actually. Ooh, that one was close. So one of the tricks I do is if you actually get a rocket to explode one of these guys and he drives through it, it hits him as well.
Oh.
So you don't have to hit him directly necessarily.
It's like
collateral damage.
Air bursts, yeah. But I have to go all the way. Oh, there he is.
Oh. I'm glad you've seen this game before. You're the first guest that actually tried to play it ahead of time.
Yeah, I didn't make it nearly this far.
Yeah.
I guess I have infinite rockets also in this sheet.
Yep.
I just got to practice firing the rocket. For some reason, it really doesn't feel reliable to me. That was gruesome. I always put giant gold pictures of myself in the lobby of my office building. It's really tasteful.
I'm just going to assume that does exist in your office at work. I've never seen it, but now it's lore. Oh, now it's declared as fact. All right, so we're playing NARC. We have about, I don't know, 5 minutes left, depending on how long it takes you to battle the final boss.
I mean, this is it, right? I gotta kill him out of his wheelchair, and then he turns into like a giant skeleton or something.
Yep, that's exactly right. And so... if you have any last minute questions you have for Ted Kolberg, he's happy to answer anything about high energy particle physics, the Large Hadron Collider, whatever it might be. Throw those questions in there right now, because you have until he kills Mr. Big for him to answer them.
Yeah, so maybe 2 hours.
This is the most frustrating, well, no, the next one is the most frustrating boss in the game.
I can't get this. There you go.
Yeah, so the Nintendo, so this is an original Nintendo controller, so you don't have to press it down all the way. If you press it down all the way, it's going to cost you like 4 frames. Yeah. So just, you're really gentle. There it is. And then he's going to inchworm off. So this is Mr. Big, round 1, killing the wheelchair boss.
But now I still need a gold key card. Is that going to come from one of these
So
regular
you're going to have to shoot him 3 more times, or 2 more times.
Joking me.
Yep.
All right. If something's...
All right, I'll throw my questions in there, because you were excited about 2 questions in particular, or 3 questions in particular. If you had unlimited resources and no moral qualms, what experiment would you conduct?
I think it would be really interesting to just let global warming like run, just let it happen, and like see what happens. What would happen?
I mean, you could amplify it too if you wanted to.
You know, this is one of those things where the basic science is pretty well understood, but like how it would actually work out in real life and how much. You know, these IPCC reports or whatever, it's all like good stuff that people are doing, right? They're doing their best, but it's a very complex problem with probably a lot of variables that we don't fully understand. And I just, you know, we're going to spend a lot during our lifetime to head off this problem that we're like pretty sure, but not 100% sure is actually needed. And for a physicist, like a lab scientist, I find that idea very frustrating, right? It would be really nice to have like Earth 2 to like run the actual experiment and know like exactly what's going to happen and when, and then you could invest much more intelligently in how to solve it. Like again, comparing with the like state of science during the pandemic, right? We've had like quantitative models of what would happen with the pandemic that have been basically completely wrong at every turn, like nowhere close.
Yeah.
And it could well be the case that the same is true for global warming. I shouldn't say, I'm not like a global warming denialist or whatever. I think it's absolutely worth investing like a significant amount in overcoming this problem, which is almost certainly going to cause a lot of bad impacts for people in the world.
There you go. Nice. That was the third.
Still, part of me wants to know like what's the real scenario that we're averting? So
my major contribution to this speedrun is, you know how he like falls to the ground and inchworms to the right, and then it takes another 15 seconds for him to spawn? If you despawn his body off the left side of the screen, he doesn't inchworm right, and it resets the cycle and he comes in right away. And I found that through trial and error, and that's it.
You're assuming that's a bug, or it's like a secret feature?
I think it's a bug. I think they didn't know if you despawn him. That inchworm animation triggers something that takes time. It's
unsettling, that inchworm animation. The idea that you blow up someone in a wheelchair and they then kind of like scurry off like a cockroach or whatever. He's a really unsavory character.
When we described the bargain bin nature of some blockbuster games, this perfectly encapsulates that. Like this is that kind of game. Bells Express, thank you for joining us at the last minute. If you have any last minute questions for Ted Kolberg on high energy particle physics, throw them in chat right now. He's going to answer while he fights Mr. Big.
I just rocket him until he turns into a skeleton.
So if you go to the top of the screen, he can't hit you with his tongue, but you also have to jump and rocket him in the hat.
Rocket him in the hat.
Yes. Imagine you're the 8-year-old kid that got this game and got all the way to this boss and had to figure out that you had to jump and rocket him in the hat.
Oh, 25,000.
Holy crap, you got it. Nice. So now it's just rocket him in the face. So did you see the compilation? I sent it to Rachel, the scientist versus Mr. Big.
I watched it. Yeah, I watched it on YouTube the other night.
So now
I was consuming all the NARC
training
materials that I could while avoiding actually playing the game.
Yeah. So now it's just bullets, but you can't shoot them at the top of the screen. You have to be lower. For some reason, it only makes contact if you're not at the top. I don't know the rules. It's just the way it works.
And does he have like a magic weak point? That'll come later, right? He's going to show his like glowing orb or whatever.
So yeah. So you got 2 of the vertebrae. So now you'll have to like reposition. Your firing at these is dependent on your Y position on the screen as well as the time you start shooting. And so it's really... They tried to be really creative to make this like RNG where it's random number generated when you can hit him, and they took into account your X, your Y position, and the firing rate, which is crazy complex.
That my bullets only will damage him? Yep. I shouldn't use rockets?
Rockets won't do anything to him.
Oh, I see what you mean.
Yeah.
Boy, is that fiddly.
No, it's very, very fickle. And so my brother has completely reverse engineered this boss, and he can beat him in like 4 seconds with the tool assisted run. But human made motions, you can't do it that fast.
You should try to make contact with the original like software engineers and see if there's like source code for this game available.
Well, he's done that. That's what he's doing essentially. So he's reverse engineering it from the actual code.
That's interesting.
Oh, there's another one.
Yeah. So. I feel like we should take this thing to like a lab and like study it. Like this destroying it with a gun seems like
there you go. It's,
clearly Mr. Big was doing some like exotic.
Yeah. No, he has technology we haven't yet grasped. So I agree. All right, this is the last level. This is civil forfeiture. The level. We go through and collect $24,000 gold bars.
I guess in the speedrunning contest, there's not really any advantage to the.
Nope.
Civil forfeiture.
All right.
I remember the dare officer at our school like bringing like, cool cars that he sees from like drug busts or whatever. Man. Not quite sure what message that was actually sending to the kids. But.
Oh, so here it is. Nice work. Contact your local DEA recruiter. Ted, you found a new career option. Congratulations. You beat Mr. Big. Fun factoid, if you put in ass, it doubles your score because, you know, classic gameplay.
All right.
There it is. You've won the war on drugs.
471,400 points and 22. Oh, we almost hit the 2-2 thing on 2-2-22, but
yeah. I
guess we'll have to try again next time.
I mean, so that's probably
2-player next time, right? I want to have the 2-player experience.
If you want to warm up the speed run, I think the record is something like 9 minutes and 56 seconds. So it's beatable.
It's beautiful.
All right. Well, everyone, thank you for stopping by Ask a Scientist Gaming. Again, mediocre gameplay, expert level science. So we appreciate you coming by, dropping questions in chat. That's what makes it a lot of fun to sit here and discuss science with my guests. So, yeah, it was awesome to have everyone. Ted, any parting words for the audience?
Don't do drugs.
Don't do drugs. If anyone has suggestions on people we should raid, throw those in chat. We'll do a quick raid. I don't know, like a minute after we close out the stream. But thank you for stopping by. Alpha, welcome for being a first-time visitor. It's a pleasure to have you. In 2 weeks, we may have Allison Wing. She might have a scheduling conflict, but she's a meteorologist that actually models cyclone formation. But either way, we'll have something on stream. Mitchu, thank you for stopping by, and thank you for the first time chat. It's always a pleasure. Until next time, I guess we'll see you guys later.